But my internet stopped working temporarily. One thing that I saw here is that if I do a print statement and I put it here, it's gonna show a comma there. Well, now I'm using args, but this thing doesn't work as well. Oh, maybe if I do module name equals args. Module name. Maybe if I do it like that. Yeah, but same thing. And then stops executing. It's not even running through this file because it's not printing column name. And if I do it like this, then it shows with a comma here. And I don't know how to get rid of this. Oh, now it worked. Huh. Now it stops. So the problem must be I don't know actually. There's also another print that I need to take this off. So that should be this file name here. That is the problem. But apparently it ran twice. Compose. No, but then it ran twice on a row. Hmm. And then it stopped working for some reason. I should have put a print statement here. Should know how many iterations it went through. Stop. And now it doesn't run. So if I erase this, or maybe I have to close this altogether so it works.
So you can go for every 1 minute. If you have the empty bracket, it will go for 1 minute every 1 minute. If you define something, then it will go with it based on the 12 minutes. Now we have other ways of doing scheduling a job. So for example, we can go for every minute at some particular seconds. Every minute dot at some 10 seconds to some. So what this will do is like if you define the job, it will run the job at every minute. So like if you define it 2 minutes, so 2 minute 10 seconds, at 2 minute 10 seconds it will run. If you give a minute as 2 minutes here, then every 2 minute 10 seconds the job will run. This is what it is going to do. Next, we can schedule every day. How we can schedule every day? Dot every day. Sorry, schedule every day dot at some defined time. See, 12:30. So this will run your job every day at this particular time. So make sure this is in your 24 hours format time. So if it is AM PM, so you should be very careful. So this will do it every day. Now we'll say like we can define a day, say like Monday or Tuesday. So we can have directly at every Monday at 12:30 do the job, or we can go for every Tuesday 12:30 do the job. This is how the schedule works. This is pretty simple. This is pretty simple liner codes. And if you like my video, please press like button. And for more videos, please subscribe my channel. Thank you for watching.
Hmm. Yeah, but this also doesn't work. So I'm gonna try the limited stuff. Hopefully it works. Oops. Yeah, lambda, then the job with the arguments. Got kind of tired today, I don't know why. Yeah, it stopped working. What can I do? Why is this shit not working? Maybe if I change the name of this thing. Or GB. Scalar. So the problem is the count file. Hmm. Let's see how long this runs. Oh, we ran to the third one. No, it runs 2 times only, just like the other ones. So it might not be the count file. Something must be wrong with this. Yeah, and the second time. It also gives me this graph. That doesn't make any sense. It's GP, not me. GB, not GP. Hmm. What is going on? It's so weird. Oh, no, here's SCV, CSV. So it should be reading the file. Yeah, there shouldn't be the problem. I'm trying to print this. It only runs once. Even though it's on a loop. That doesn't make any sense. What is going on here? Now it runs. Huh, that's really weird. So it has to be something with the count file. The way that I'm doing this. Yeah, now it runs twice and then it's done. Maybe it's because I'm closing the file. Let me see. Doesn't work. It runs twice and then it stops. Print Y. Print. Might be this condition that is the problem. So it's 3 on 1. Oh, I need to put like this. So dumb. Oh my god. Oh man. So I need to redo all this stuff. Guess it's because I'm kind of tired today. Don't know why. I think I'm thinking about too many things at once. Damn, hopefully now it's gonna work. Let me redo everything that I did. The thing is, because there are a bunch of scripts involved, it's also hard to think about all the possible things that can be wrong. Hopefully it's gonna work now. Yeah, I think that's it. Now let me delete this stuff that was created here. I also need to see if there's a way to create the formats into different files. Because every time that he renders this, he creates the file both in PNG and the other format. I hope it works now. Let's see. Yeah, let me delete this one. I'm not using time, so maybe I should put time there. Nah, I'll do it without time. Fuck it. Just gotta see if it works first. Yeah, apparently it's not running the script. So there must be a different problem as well. Oh, so maybe it was the file close, not this thing. So I think this condition was correct, maybe. Because y has to be bigger than the length of the data frame. Smaller in order to run. Well, let me change one thing at a time and see if it works. And even though I'm scheduling, it's not creating the full graph as well. There must be something else that I'm missing. So let me delete this. Yeah, it should be this thing here. That's probably the problem. But I just don't understand why. It's both this and the graph that is not working. So only when the script stops the execution, it creates the file. But for some reason, on the first 3 iterations, it works. Maybe I should erase this block and just have the file, just create the file manually. See if it works. But I have to write it each time anyway, so it's gonna be a problem. Yeah, I think the condition now is true, is correct. This condition now is correct. So maybe I should check if there's a way to create multiple graphs at the same time. Then it's gonna be a lot easier than trying to fix everything. Trying to figure out what's wrong with this schedule and CSV. Let me watch these videos first.
Pro, and in this short video I'm going to show you how to automate Python tasks so that it could run as a schedule, so that it can run every 2 minutes, every day or every second. So this function, you should have a function you want to run. So we have this function here, show name, Times on the Tech Pro, subscribe and like my video, and I also remind you to subscribe to my channel. So I want this function to run every, let's say, 5 already installed schedule. So the next thing I will run pending. I'm going to run this code now, and let's see if it runs every 5 seconds. So let's run.
Hey guys, in this video I'm going to show how can you schedule your Python scripts to run at certain intervals of time on any Unix or Unix-like operating system, that is any Linux distribution or any Mac system and so on. Let's consider a scenario where you have written a web scraper for scraping a web page on which the information keeps changing after short intervals of time. For example, it might be some news website or any stock market website and so on. So now you have to run your web scraper at periodic intervals of time, let's say after every 1 hour. So how can you go about doing that? Well, there are very two simple solutions here. First one is that you can manually run your Python script after each hour. So in this solution, you are actually the timekeeper, and that's why it is not a very reliable and feasible solution. And another solution is that you can use an infinite while loop with time module's sleep function. So basically, in each iteration, you can simply execute a scraping task, and then you can put a sleep of 1 hour, and this cycle will continue. But the problem with this approach is that no one wants to keep their Python script running uselessly and infinitely, because it's quite resource intensive in a way. So now, what we can do now after seeing these two solutions? Well, a better solution here is that you can use something called a time-based job scheduler. So a time-based job scheduler can take any job or command for execution along with some time schedule from any user. So a user will provide two things. One is the command to be executed, and second, the time schedule according to which that command has to be executed. So what happens behind the scenes is that a background process keeps running by the job scheduler, which is responsible for running the command if the schedule provided by you matches with the current time. So in this way, a job scheduler works. So one such scheduler for the Unix environments is cron. So the cron word has actually been coined from the term Cronus, which is the name of a Greek god who is a personification of time. So it's quite an accurate and very nice terminology which has been used here for naming this particular word, right? So cron is the software utility which we are going to use for scheduling our Python scripts to run at certain intervals of time. So that is what we're going to see this particular video. So without any delay, let's get started. Okay, so first of all, let me tell you the basics of cron. So cron is actually driven by something called a cron tab file. So cron tab is short for cron table. So a cron tab file is actually like a configuration file which specifies the commands which I have to run periodically on a given schedule. So that is what is defined in a cron tab file. And the basic syntax for a cron tab, for a schedule in the cron tab file is something like this. You have to provide 5 parameters, these 5 values, and then you have to provide your command to execute. So what are these 5 parameters? These are, the first one is the minute value, then the second one is the hour value, then the third one is the day of the month value, fourth one is the month value, which is which month of the year we are talking about, and the last one is the day of the week value. So these are their ranges, like day of the week can range from 0 to 6, starting from Sunday up to Saturday, then month starting from January to December, then day of month 1 to 30 minutes its range, hours it has a range 0 to 23, and minute has a range 0 to 59. So we do not have any parameter for seconds actually, so the minimum interval that you can have between your job executions is actually 1 minute here. So this is the basic thing that you need to know about the syntax of the job schedules. So now how do we specify our schedule for different kind of cases? Let us try to see. Let me just remove that. Okay, so by default, what we are seeing here is 5 asterisks. So 1, 2, 3, 4, 5. So what does this mean? Actually is that we are going to run a job at any value of this particular parameter. That is what asterisk means. So it is saying that at any minute, at any hour, and then on any day of the month, in any month, or any day of the week, I want to execute this command. So what it simply means in simpler words is that I want to run my this particular command after every minute. Okay, so now what if I want to run a command after every hour? So for doing that, what you need to understand here is that now when you talk about hour, minute should have a specific value, like in every hour, in which minute you want to execute that command, right? So let's say you want to execute this command after every hour at just the start of that particular hour. So for doing that, you can just put the minute value as 0, and then you can put 4 asterisks. So this is the schedule through which you can run your any kind of Python script, or you can run any command on your initial command after every 1 hour. So now let's say if you have to run a script daily, so what can you do in that particular case? So if you have to run a script daily, then you have to decide at what point of the day do you want to run that script. So let's say you want to run the script at just the start of the day, which is the 0th minute and the 0th hour. So you can just put 0, 0, and then you can put 3 asterisks. So in this way, we can simply specify the particular time at which we want to execute a script. Let's take one more scenario. Let's say we want to execute a particular command after every half an hour. So for specifying after every half an hour, what can we do here is that we can provide 2 values of the minute parameter. So I can just put 0,30, and then I can put 4 asterisks. So what is saying that on every hour, if the minute value is either 0 or 30, I want to execute my command. So it simply means that you want to execute your script after every half an hour. Also, if you write 15:45, that will also mean the same thing, just the offset has actually changed. So let's say you execute a script at 5:15, then it will happen at 5:45, then 6:15, 6:45, and so on. So in this way it works. Let's take one more last example here, which is, let's say you want to run a Python script or any kind of command on 5:30 a.m. of every Saturday. So let's say that is the scenario, 5:30 a.m. of every Saturday. So what you can do here is that 5:30 a.m. can be specified by doing 30 and 5. So these are 2 values. And after that, you do not care about the day of the month, you do not care about the month of the year, but you care about the day of the week, right? So Saturday is actually the 6th day of the week according to this. Well, not 6, it is actually 7th day and is having the index 6. So I can just write 6 here. So in this way, we have specified a schedule which will execute a command on every Saturday at 5:30 a.m. Okay, and yeah, one more thing that I forgot to tell here is that let's say on any particular day, or let's say daily, you want to execute a script after the intervals of half an hour, but only from 9 a.m. up to 6 p.m. So let's say it's some office work and you have to execute that particular command after every half an hour, but only from 9 a.m. to 6 p.m. So how can you go about doing that? So you have to execute the script after every half an hour. So let me put the minute value as 0 and 30, but I have to execute it from the hour value is having the range 9 to 6 p.m. can be specified 18. So it is 9 to 18. So you can just write 9, 18. So you have to use a dash symbol here. So 9, 18 is the value of the R parameter, and then you can just put asterisk. So in this way, we have specified another kind of schedule, which is going to execute a script daily from 9 a.m. up to 6 p.m. at intervals of 30 minutes. So in this way, this is going to work. So these are the different ways of scheduling, of specifying a schedule for your commands. And also there are some aliases or some predefined scheduling definitions. For example, there is something called @yearly. So this is just an alias. You can just write @yearly and then you can put your command. So @yearly is simply equivalent to 0011 asterisk, which simply means that on the 0th hour, on the 0th minute, 0th hour of 1st of January, you want to execute a script, which simply means that you want to execute a script yearly, right? Similarly, we have monthly, weekly, daily, hourly. But one more important thing here is that we have something called reboot. So what @reboot will do is that it will execute your script every time the system is booted up. So every time you restart your computer, every time you start your computer, what will happen is that the specified command will be executed. So this is how reboot will help you. So yeah, so these are all the different examples, and I hope that you've got a bit of understanding of how to define the schedule. And now it is time to do some practical things. So let's see how to schedule a Python script execution using cron. So here's my terminal, and on my desktop folder, I have a file called test.py. So let us see the contents of test.py. So test.py is actually a fairly simple Python script in which I'm just importing the OS module, I'm importing the time module, I'm printing running, and I am creating a directory in my current folder whose name is equal to the Unix timestamp, which I'm getting by calling time.time function. So it is a very simple script which is just creating a new folder, which is just printing running, and that's it. So let me just try to run it. So let me just do python 3 test.py. So look at that, it printed running, and we got a folder whose name is somewhat equal or related to my Unix timestamp, current Unix timestamp. So if I just run this command again, I get running again, and I get another directory in my current desktop folder. So in this way, this particular script is working. And now I want to run this script after every minute. And for doing that, I'm going to use cron. So you have to specify your job schedule in the cron tab file. And for doing that, you have to do cron tab -e. So -e means you want to open the cron table in the edit mode. You can always just see your cron tab or cron table by doing -l, which will simply show it to you. So
Yes,
this is my cron tab file right now, which is just having some comments because there is hash here, right? So let me just open it in edit mode. So here I have my cron tab, and right now all the lines have been commented. So here let me come to the last line and write my job schedule, which I want to execute. So since I want to execute my job after every minute, I will just do asterisk. I'll just write asterisk 5 times, and now I will have to write python 3 test.py. Now this is actually the command which I was using for running my Python script when I was at the desktop, but according to cron, according to the background process which is going to run this particular script or this particular command, that process doesn't know that I have to be at the desktop for executing this particular command. So what we can do here is that we can do cd. Okay, so it just removed it all. So let me just write it like this. We have to first of all move to the desktop, cd desktop, and then I'll put double end, which means that after moving to the desktop, I have to do this job now, which is python 3 test.py. So now it looks better. So I will just first of all move to the desktop, and now I will simply execute my another command, which is quite local to the desktop, right? Because my test.py is at the desktop. So this is fine. But now another thing that you must know here is that cron actually uses a shell called sh for executing your shell commands that you provide here. So sh shell is actually quite low level, and it doesn't know about some aliases like python 3. It doesn't know what is python 3. So python 3 might not work as expected for you while you are using cron. Okay, so you might need to provide the absolute path to the interpreter, to the Python interpreter that you want to use here. So for that, you can simply do where is python 3. So after doing that, you will get the different paths to the different Python interpreters that you have installed on your computer. So /user/bin/python 3.6 is actually the path to my python 3.6 interpreter. So I'm just going to use that for executing my command. So let me put it like this. So /user/bin/python 3.6 test.py. So in this way, it will execute my Python script. And also, I want to put all the output.
I think I'm gonna make some coffee. I think a while ago, I said I was gonna wait for 2 weeks until I drink coffee again. But yeah, I don't remember how long that was. Probably not 2 weeks. Yeah. But I don't know. I think I'm tired now. I think I'm gonna drink it, and then I can do the 2 weeks after the New Year's is over. Cause I'm kind of sleepy today. I'm not sure why. And I don't wanna go to the market and get some energy drink. So it's pretty much gonna be the same thing as coffee. So I was rolling the RNG there to see if I would do it, and I got less than 50, so I think it might be worth it. Yeah, I think I would do like this. I would drink coffee until the end of the year, and then once the year starts, I can do a detox of 2 weeks or even a month. That way, I can set up the momentum for the year as well. Yeah, so I think that's what I'm gonna do. And weirdly, this started working. I think it's because I deleted the close file thing here, and I comment this out. So this two things must be the problem. And now apparently it's working. So it's definitely not this, because otherwise you wouldn't run the function. It's definitely not this. So it has to be something to do with this and the count. But I think the graphs are not gonna be the way that I want them. I want them to be, based on the previous times that I was testing this. It wasn't saving the graph properly, so I'm probably gonna have to research how to build a bunch of graphies at the same time. And then if I manage to do that, then it might not even be necessary to do this whole script here. I can just do this one, a simple for loop, and then iterate through the files. But I'm gonna be right back. Maybe I'll meditate as well a little bit for 5 minutes or now. whenever I have situations like this where I break the promises that I made, I try to do some compensation and some extra work or something that is painful, so it balances out. And obviously, I'm trying to minimize as much as I can situations like this. But yeah, I think you can't be too hard on yourself, and you have to be flexible and dynamic. Otherwise, you can't really improve. If you're always trying to expect too much of yourself, you eventually quit. Uh, so sometimes you gotta uh, be flexible, and yeah, and you gotta assess the situation and see if, for example, you're gonna train in the gym and then you're not really feeling like it. There's no reason to go absolutely insane because you're not working hard. You're not working smart. You're just working hard, and then over the long term, it's probably gonna be less beneficial. So in those situations, it's probably better to just let go and say, okay, I'm just gonna do some shitty work today. I'm gonna do go really light, and then I'll compensate somehow afterwards. And that way, you have both sides of the symmetry. Now, obviously, people tend to deviate either to one side or to the other because some people don't. Then they use this as an excuse to rationalize and not work hard at all and not do anything. And that's why this kind of mindset can be a problem if you're in that state. But if you're more on the David Goggins state, let's say, where you just work extremely hard and you're used to it, I feel like it's more beneficial and challenging to be able to let go of your discipline. And that way you get more closer to the flow. Because then at that point, your comfort zone is to work hard. And I think at this point, I'm more on the David Goggins side, where I work extremely hard. And I got used to studying and working every time. So sometimes it's good to just be flexible and let go. But obviously, there's a balance to there. So to that, so I have to be careful. So I think today, since I'm going to drink the coffee, because I'm tired and my mind, for some reason, is kind of foggy, like I'm not being able to think properly, then I'm just going to spend more time streaming and studying. So I think I'm going to spend at least 8 hours today. So I'm going to go finish the coffee. Alright, so apparently it stopped running the script here. And all the graphs are fucked up anyway. So I have to delete all of them and figure out a new way. Obviously, what I'm doing with the coffee is not ideal, but I think it's kind of like it reminds me a lot of the way that I think about the church and Jesus, church versus the spirituality. The church tries to force the institutions that use spirituality as a weapon, try to force people into getting into this frame where you're reprehended or you're shamed for doing things that go against the philosophy of the religion, because it's about a battle of the morals, and the institutions are trying to use the spiritual teachings to control people. So, and I don't agree with that way of looking at it. I think if God exists, or which I do believe that that's the case, and the spiritual teachings of the sins and this stuff makes a lot of sense, because when you sin, you become weaker, because everything you do in the short term that makes you strong, makes you feel pleasure in the long term is gonna make you weaker, and vice versa. So, but I don't think it should be forced upon you to do these things and to live the archetype of Jesus, which is the ultimate sacrifice for the ultimate power and strength. Which means that if you sacrifice everything and if you die on the cross, which means that you accept all the suffering of life and pain, you become free, because there's nothing that can affect you. I think that is a fundamental truth, but you can't be forced to be on that position, because ultimately there is no answer to life. It's just a matter of perspective. So, and I think Jesus was probably that way if he really existed, not the way that people think about it. Because people like to put these types of people on a pedestal so they don't have to take responsibility for their own lives. So they invent stories about these figures in order to rationalize their own behavior. But I think the way he probably was is more like, if you, this is probably the best path to go, but if you don't go throughout this path, it doesn't matter, because everyone is on their own path, their own journey. And that's my philosophy right now, is that there's nothing wrong with doing things that give you pleasure temporarily. You just have to be conscious and aware of the consequences of those actions and understand how they're going to impact your future. So when the time comes where you're going to receive the payment for that transaction you made earlier, you're not going to rationalize that pain and use other people as scapegoats for your actions. The way you are way more likely to correct yourself in the future in case you're not able to handle the pain that came from the actions you took. So let's say, for example, you eat sugar every day. If you are aware of what you're doing, once you get diabetes, you're not going to be able to say, wow, these industries are responsible for this and that. And that's what your limbic system is going to do, because it's trying to find things that are not 100% false and not 100% true, in order for you to justify your behavior that doesn't make any sense. So you can keep doing the bad thing without getting responsibility for it. And even though the excuses you're going to make to yourself make sense, they are just excuses. And deep down, you probably know that, which creates shame and resentment. But if on the other hand, you are aware of the things you're doing, and you understand that, well, I'm eating sugar right now, I'm probably going to get diabetes in the future, and I'm willing to pay the price for that. Then you eat it and then get diabetes. When you get diabetes, it's gonna be painful, but then you're gonna realize, well, I made the decision to eat sugar, so it's my responsibility, and I accept the pain. And to me, that would be the same thing as not eating sugar and exercising. It's just then a matter of taste of each which way you wanna live, which story you wanna create. But at the end of the day, it's just stories, and doesn't matter that much. It's just about the vibe that you wanna exist.
produced by test.py, like all the print commands which are producing some output. I want to put that output to some file because actually background process will be executing my Python script, so I cannot see the output which is getting printed, right? So I can simply save it to some file, and that is what I'm going to do by using this symbol, this double greater than symbol, which simply means that append to this particular file, which I'm going to call test.out. Okay, so it will simply be appending all the output to a file called test.out on my desktop. So in this way, we'll be actually, you can say in a way, logging some print statements which are.
I think what I need to do is search for how to save multiple of this at the same time. Python. I don't understand why the graphs specifically it seems to happen this. I think it's all the graphs is probably something that has to do with the backend of how graphs are made. Maybe I can run this script and study matplotlib a little bit. Run it manually. Oh, I have to run the other one. Because this one is made for arguments. Import matplotlib. Maybe I have saved already. PNG. Oh, I have it here. But I think that's the basic one. And where is it here? It's gonna be a little bit complicated. So it starts on org Python core. I assume these are the files of Python, probably. So let me see. I think that might be a good idea to do now. It's probably not gonna solve the issue, but I can search the issue later. I'm just curious to see the functions of matplotlib behind the scenes. Oh, so it's not a side package. Hmm. So maybe I should focus on understanding the way that this is being built, because I don't understand it very well. Like, I need the location of the files, not just the files. And I was thinking about doing is, other than doing like this, the graph, the way that is being done right now. I was thinking about creating something that follows the frame of execution when you run a program. That way you can follow the program, the script, line by line, let's say. Kind of like a Python script visualizer, but for big applications. And that would probably be very, very helpful. Because then I can just run the script and see what is calling what. each time. To me, that's the biggest problem so far. So let me see if I can find these files here. Is there a way to search for files? So library root. Side packages. Yeah, it's not here. Oh, so it's probably inside matplotlib. I have to follow the arrows. Yes, so there's something weird with me today. And the thing is, there's this multiprocessing here as well. Multiprocessing in matplotlib. And they exist outside of the scope of the matplotlib thing. Oh, so I guess I understand now. Whenever there is the square, it means the files exist inside of here. Oh, but then this means that these files should come from outside. Oh, so these files exist in copy. So maybe I should look for a copy instead of these ones. So whenever there is a square, it means that the main file comes from, all these other files comes from this one. This logging I see all the time as well. Just logging, copy. This multiprocessing stuff. Should be interesting to look. Yeah, so logging is here. That's one file. Pipe parsing should be here as well. So copy comes from pipe parsing. There's also cycler. C times. Yeah, cycler doesn't exist here. So this is also a problem. Not only I need the name of the files, but I also need the way to figure out where they are. Let's see, by. Yeah, it's not here. Oh, PyDoc data. It should be pipe parsing. So let me open the site packages and see if it exists inside matplotlib. What? Matplotlib's not here as well? Maybe they don't have imported? How is that even possible? The script wouldn't work if I didn't have matplotlib. And it has to be on side packages because of the way I built this. Or that Vivex built this. Maybe not. Hmm. It doesn't necessarily need to be there. On Breadpack. So I'm gonna change the name of the stream as well. So where is this thing? Oh, it's here. So matplotlib Then it should have a login cycle. Yeah, but it doesn't work like that. So that's another problem as well. This doesn't show me what I wanted to show. That's the thing. Because what I want is a different thing. What I want is to know the scope, the execution of a program, what the flow of the files that is running through. So I don't have to look at all the files all the time. The files that I'll look at is the ones that depend on the programs that are being activated. So let's say out of all these files, a program uses this animation data. Then I want the thing to come here to this file, and then after this file is ran, then it shows me the other file that ran. So let's say this file calls this file. Then I want to show me that it goes from here to here. But I need to have the location of the file as well. Or I need to create it somehow in a way that allows me to follow the execution. Line by line. I'm gonna close this for now. So I think the best thing I can do even before do the graph is study this thing. I need to study first. And then I'll create a script that actually has what I want. Which is probably gonna be tough. So I'm not sure how long it will take me to do that. How can I call this file? Testing? No, that's fine now. I'm gonna copy from here initially and then modify it as I go. Actually, I wanna copy this version here first. And I'm gonna put it as PNG for now. I'm also gonna delete all the print statements. This just plugs up the page. Delete numpy. I think I'm gonna meditate now for around 10 minutes, then start drinking coffee and study this stuff. I think I'm gonna read this article here. I made an account the other time when I was offline. I'll close this, close the documentation. This is the Viz network stuff. I think I'll favorite this and see you later. Because this is for the future once I get everything the way that I want. This is the C++ stuff. I was also watching some videos
Hey, what's up, guys?
on C++. I really like this guy's tutorial, so I might watch these videos later as well. And import lib stuff. So I'm gonna separate these things here. What should debug? C++. I think I'm gonna close the free code camp tab. Probably not gonna do free code camp anymore. Even though, yeah, I might come back to it, but yeah, it helped me a lot. That's for sure. So now I think this is good way. So C++ here, then I have this crypto zombies, which is for solidity stuff and blockchain, which I have to do some time, and then I have the Python stuff. So I'm going to meditate for 10 minutes. Oh, actually, and this was the counter for 4 hours. So I'm here for 3 hours already. Let's see. I need an alarm clock. No, that's. Oh, I need this one. I think I'll do it with my cell phone. It's probably easier. Maybe I'll do it here and reset this counter. Yeah. That was really good. I had an interesting thought that I think when I was meditating with this for 5 hours, that computers might be self-aware already and we just don't understand it. Because in the same way that a computer is turned on and turned off based on the user, it's kind of like we work in the same way. So what we call this is sleep. So it might be the case that when you're sleeping, it's just the universe turning you off, and when you wake up, it turns you on. And it might be a cyclical chain of connections that work like that with everything. And computers are part of that. So in a way, the idea of ego is just a configuration of the electromagnetic system. And the experience itself of being an observer inside of a field is the configuration of that electromagnetic system that happens spontaneously in some situations. That's what's happening with us and with everything. It's just like a giant ocean of electromagnetic waves, kind of like string theory. And consciousness and the experience of observing things are being controlled is just part of that. It's just what happens in a specific configuration of that field that exists forever. It's an interesting thought. I think it's probably true, but yeah, anyway.
Guys, welcome back to the channel. If you're new here, my name is Frank Milarczyk, and in this video we're actually going to be talking about how to run your Python scripts basically from anywhere at any time that you want, and you don't have to have any sort of internet connection or electricity or anything like that, and best of all, it's free. So before this, I had some scripts I was using to update some data in my spreadsheets that I was using to track my dividend portfolio, and the problem I was having is that basically I had these set up to run with the task scheduler on my Windows computer, and this is working well for the most part, but the problem is that it does not work if the computer is not turned on or if you don't have Wi-Fi or something like that. So I was kind of looking for a solution where I could basically run this on a server, essentially, that is hosted somewhere else. So that's basically the solution I found, and this solution is actually free just because of how it's set up. So normally you would have to pay for a server, but this is free the way I'm doing it. So that's what we're going to be talking about today. If you do enjoy these kind of videos, make sure to like the video to show me that this is the kind of videos you want to see in the future, and also subscribe if you want to support the channel and see some other videos in the future as well. So we're actually going to be using a website called repl.it, and this is basically a website you can use. It's basically an integrated development environment, but it's not a program. Basically what it does, as you can see over here on the left side, these are my files that I have in this package, I guess, or file basically. So this one right here is just called keep_alive, and this is the one that basically creates the server and then runs it forever basically. So I'm using Flask to make the server. So this right here is basic code to create a server, and then I'm also using threading and a thread, and this allows me to continue having the server running but also have my other Python code running at the same time. So a thread basically just allows you to do two things at once. So I'm making this function keep alive, and then I'm starting this thread here so that this keep alive file will just run forever while my main file is running. So I have my main file, and I'm importing the keep alive function into it. And then this is mostly basically the same stuff I have in my regular script. So here, all this stuff down here, right here is just like authorizing my script to import into my Google spreadsheet. And then down here, this stuff is just getting all the data and inputting it in one piece at a time, right? Which I've showed in previous videos before. And then right before I start this while loop, this while loop basically is the part that runs forever. So I'm going to put all my data in and then just have it run again basically. So before I start that while loop, I'll do the keep alive function, and that basically just starts my server up and continues that to keep running forever. So once I get into this while loop, I just say while true, which basically means it's going to run infinitely long. And then this is all my code to get my data into my spreadsheet, which is the dividend date, the ex-dividend date. I have the dividend amount that I'm getting the beta, and also the 3-year dividend CAGR. And then also at the bottom here, I added this new part, which puts basically a timestamp into my spreadsheet so I can see when it was last updated, which is pretty nice, just to verify that it's working. And then at the very end here, I have time.sleep, 259,000 seconds basically, and that's basically 3 days. So I decided I'll just have it update every 3 days. So after this updates all this information, it's going to basically wait 3 days and then update it again. So if we, and also this Sheets API key file here, that's just the file that you have to use with gspread to be able to be authorized. So I had to include that here because when you're authorizing your scripts, you have to use that right about here. So that's what that is. That's that third file. So right here, just going into my portfolio spreadsheet, if it will load, there you go. So here's my spreadsheet, and then right here I added this little thing. It says last updated, and then it will put a timestamp in there. So it was last updated at 12:30 on January 14th, which was fairly recently, just a few hours ago. But the problem with this is that REPL, it only keeps your server up for about an hour if there's no activity. So since I'm waiting a few days each time I update this information, if I just let this run like it's running now, it would just eventually go down after about an hour. So what I have is there's this free service called Uptime Robot, and basically what this does is it pings your site every 5 minutes, and you can, basically this is just checking that your site is active, or your server is active. It's basically the same thing, and this is free, and during that pinging, it makes REPL think that your server is getting some activity on it, so then it doesn't shut the server down, basically. So I'll show you how this works. Basically, if you want to create a new account, you just register, but I'm just going to log in, and this is completely free, so that's a great thing about it as well. So just log in. So this is just my dashboard here, and so basically it's just showing I have 2 monitors, which are shown over here on the left side. One of them's for me, and one of them's for my brother, because I'm helping him with some of his stuff on his portfolio as well. So this basically just shows the response time of the ping, I guess, so it's some milliseconds, and you can use that for other things if you really care about exactly how precise your site is, but it's not really a big deal in my case. And if I try to move this a little bit, you can see that it shows you like the last 24 hours, last 7 days, last 30 days, how much it's been up. So basically this has been up for 137 hours, which is basically when I started this a few days ago. So I've been just working on it the last few days and just making sure it's all good. Then now I'm making this video on it to show you guys. And the one thing I did forget to mention is when you go to create a new monitor, you have to input this URL. So in REPL, at the very top here, this is basically showing you the website per se that you're creating. And so you just copy this URL here. And then when you go to add, if you go add a new monitor, it'll bring this up. And then let me try to move this a little bit, sorry. It'll bring this up, and then you just select HTTPS and then put in a name, and then you just put this URL in here. And you have to delete this HTTPS thing, but you just put that URL in there. And you can set it to do like more than 5 minutes, but there's really no point. You might as well do it as 5 minutes. And if you want to pay for it, you can have it do more often than 5 minutes, but 5 minutes is fine. And then you can also set an alert. So if your site does go down, then it will email you and tell you that. So that's how you create a new monitor. So far this has just worked great for me as a great way to run my scripts, basically with no internet, no electricity needed for my computer. I don't have to have my computer on, and I don't have to pay for it at all, which is pretty great, because normally if you want to do this, you have to like buy a server and then write this code and basically run it on a real server that you bought. But in this case, you're just using a small part of REPL's servers, and apparently most people are using such a small part of it that they are allowed to offer that for free. So I can't guarantee that they're going to keep that option free forever, but at the moment it is working and it's free, so that is awesome that we can use that. And also utilizing Uptime Robot in conjunction with that makes it work pretty much perfectly in my opinion. Now obviously if you're doing something like professional or like for an actual company or something like that, this probably isn't going to be the ideal solution, but you're probably going to have a little bit of funds to do that. So this is just a free option, I think, which is pretty awesome. So I hope you guys did enjoy the video. Remember, like the video to show you appreciated it, and I'll see you in the next one.
Pretty interesting. Very creative. Not sure how useful it is though. So I'm gonna watch videos about these concepts here before I read the article. The way I can drink the coffee.
Hey, how's it going, everybody? In this Python video, we're going to be taking a look at named tuples and what named tuples are and why we would use them. So you can think of a named tuple kind of like a lightweight object that works just like a regular tuple, but it's more readable. So what do I mean by this? So say that we want to represent RGB color values, red, green, blue color values in code, and say that we choose a tuple to do this. So here is a regular tuple. So we have color equal to, and this will be our red, 55 will be our red, 155 will be our green, 255 will be our blue. So let's say that we wanted to print out the red value. So in order to print out that red value, we would just do print color, and then we would do index of 0. And if we run that code, then you can see that we got 55 for the red value. Now what's going to happen here is that someone else is going to come and look at this code, or even you could come and look at this code weeks and months later, and they're going to read this, and they're not going to know what's going on. We have color equal
Hey,
to
Vivex, what's up, man?
these numbers, and then we're printing out the index of 0. You know, what are these numbers? Somebody could look at this and think, you know, is this hue, saturation, and light, or I don't know what's going on here. So it would be really nice if this was more readable. Now, the first idea that might pop into your head is to use a dictionary. So let's see what that would look like. So
No, that's Python 3, I believe. I'm not sure. Why though? Just looked at videos for these things. I'm gonna study these things right now. Oh, really? Oh, so the print doesn't work in Python 3. But the named tuples should be the same, right? The concept.
So let's grab a dictionary representation of this, and let's paste this in here. Now, instead of printing out this index of 0 down here, let's print out red, and let's save that. And if we run it, you can see that we got the same thing. It's 55. So what is wrong with this? Why wouldn't we choose to use a dictionary? Well, first of all, maybe we chose to use a tuple for a reason. So tuples are immutable, which means that you can't change the values. Maybe that's something that we wanted. And also, dictionaries require a little bit more typing here. So if we made more than one color, we'd have to come in and type all this out every time we created a new color. So a named tuple is kind of a good compromise between the tuple and the dictionary.
But it shouldn't change much this named tuple thing, right? I'm gonna watch more videos about it anyway, I guess. Did you work on the stuff further? I'm thinking about doing some modifications on this thing to find different stuff. And I was trying to create pen testing. Cool. I was trying to create to find a way to run a bunch of them at the same time, but it doesn't work as well. The graph just overwrites. There's something weird with the graph, the way that it works behind the scenes, that it doesn't allow you to do multiple at once. So I have to look at that as well. But I'm probably gonna change your script first to try to get different information than this. One thing here is that I was trying to find these files and I couldn't find them. So matplotlib exists on side packages, but these ones don't. And it's not really clear to understand. And the other thing that I was thinking about is that this is not exactly what I was thinking about when I thought about the graphs. I want to try to create something that is more like that reproduces the path of execution of a certain script instead of showing the dependencies. I think this is obviously a very good start, but it's not exactly what I was looking for. So I think this gives you a better overall vision, but yeah, this is useful to see the connection between the libraries. But if you're gonna study, for example, ideally you want to create a simple script that uses, yeah, it's gonna be a lot more complicated, right? I was gonna read this article here on tracebacks because it seems like the debuggers do that. So there's something there, I think, for frame of execution. I'm gonna close the window a little bit. Do you know what topics are good to study? Do you understand that?
Readability, and also it gives you the functionality of a tuple. So let's go ahead and see what this would look like. So let me copy the example I have here and paste this in. And let's go ahead and go over this. And for now, I'm going to go ahead and take out these values here. Okay, so first of all, to use the named tuple, first we have to import it. So from collections, import named tuple. And then this line here is the syntax that we use for named tuple. So we'll do that we want a color equal to named tuple, and then the name of our named tuple, and we'll do this as color. I have all this typed out up top, but I just want you to see, if you're making one yourself, the steps here. So the named tuple is named color, and then these are going to be the values of the tuple. So the values that we want for our tuple are red, green, and blue. So that's what the syntax looks like to create a named tuple. Now let's take a look at the advantages over a regular tuple here. Now if you remember when we created a regular tuple, we just did the values like this, and it wasn't very readable. And now we are saying that we want this variable color equal to color, which is what we called our named tuple here. And right now we have 55, 155, 255, and that is red, green, and blue. Now I can still use this just like a regular tuple. If I wanted to come in here and I wanted to do print the index of 0, which would be our red value, then I can print that and it prints out 55. But I can also come in here and print these out by name. So I can say color.red and print that out, and you can see that it's 55. Now you can see this is already a lot more readable than our regular tuple, because whenever we come in here or somebody else comes in and looks at our code, they're going to see, okay, they're printing out color.red. So, and then they're going to look up here and say, okay, this is a color with 3 values here, and they can make a guess as to what that is. Now, if you want to be really explicit, you can actually come in here and add all these values in, so that whenever you come back,
Already? God damn, man. How do you do this thing so fast?
you know exactly what those values are. But even without those there, somebody's going to be able to come in and see, okay, you created this from this color here, and then they can look back at the named tuple where you made that definition, and they can see that it's red, green, and blue. With the regular tuple, you didn't have that. That information was nowhere to be found. And now if you remember also, this is a lot less typing as well. If you remember our dictionary here, every time if we were to make a new color or something like that, and I'll just call this something else so it doesn't collide with our other one. So with our dictionary, this we had all this typing to do, but if I wanted to make another color from a named tuple, then I don't have to type out all this stuff. I can just do, okay, I want a color, and white would be 255, 255, 255, and that's done. And then later in the code, if I wanted to print out, say, the blue value of white, then I would just do white.blue, and you can see that that is 255. And that's also a little bit easier to write than the dictionary. If you remember the dictionary, we can't do this dot syntax, we'll get an error. We have to put that in brackets, which isn't a big deal, but it's a lot more typing. It's a lot easier just to come in here and use the dot syntax. So hopefully that kind of clears up what a named tuple is and why exactly you would use one. And also I hope you can see how this is a lot more readable than what a regular tuple might be. So whenever someone else reads your code, or whenever you come back to your code in a couple of weeks or months, then you're going to be able to take a look at this and see almost instantaneously what's going on. And with the regular tuple example that we used, that would have been really hard. So yeah, I hope that cleared any questions that you had about named tuples. If you do have any
Actually, I'm gonna watch this through more videos here about this. Maybe this one as well. Maybe I'll start with this one.
Hey guys, and welcome back.
Hey guys, welcome to Tech Vitals. Today we are going to learn about named tuple. So in the previous video we learned about dictionaries in Python. So in the dictionary we can store different keys and its associated values. And named tuple is also similar to dictionary. Here also we can store keys and its relevant values and access the value using its keys. But the process of creating a named tuple is a little bit different than the dictionary. So let's take a look at it. Now to create a named tuple, we have to import named tuple function, and the named tuple function is defined in the collections method. So we have to import from collections, and we'll import named tuple. Okay, now let's create a named tuple for date. So date equals named tuple, and we'll give the name of date. So the first parameter is the name, and then the second parameter is the keys. So we can put the keys inside the list. So in the date, we have month, day, and year. So we can add month as the first key, then day as the second key, and year as the final key. So here we have created a named tuple named date. Now we can use this date named tuple to create different key value pairs. So let's say today equals and then date. Now inside this parenthesis, we can provide the values for these three keys, so month, day, and year. So today is the October 8, 2020. So for the month, it's going to be October. So we can just give 10 as the month value. And today is 8 October, so day is going to be 8. And it is the 2020 year, so we can give 2020. Okay, so here we created a variable named today, and we use this date, which is a named tuple, and we provided these three values for these three keys. So month is going to be 10, day is going to be 8, and year is going to be 2020. So if we try to
So
print,
what is confusing about this is that I'm not sure if the name comes from the variable or does this have to be equal? What's the purpose of this one? I think this comes from this, but I'm not sure what's the use of this one here.
this today, now let's print it. So it is printing that today is the date with month 10, day 8, and year 2020. Now if you just want to get the month, we can print today dot month, and now if you try to print it, it will print 10. If you try to print the day, it should print 8. So let's see. Okay, and if you try to print, so we
But I think I kind of
Hello
get
and
it.
welcome.
What's the point of doing this?
Back to another video. In today's video, I am going to be continuing with my intermediate Python tutorials, and we're going to be moving on to something called named tuple or tuple, whichever one you prefer, which is a part of the collections data type or module, class, whatever you want to call it. So in the previous video, I introduced you to the collections module in Python, and I showed you counter, which is really useful. Today I'm going to be showing you named tuple, which is another data type or class instead of position index. So you should understand a bit of that, but if you don't, obviously I'm going to go through exactly how this works and how we can use it. So the main difference between a named tuple and a regular tuple is you can access things by element, and it's just a lot nicer to read in your program. So they might come in handy if you're coding large things or if other people are going to be reading your code. So let's go ahead and first off start by importing collections like this, and then we're just going to from collections, we are going to import named tuple. Oops. Okay. So now that we've done that, what we're going to do down here is I'm just going to create something that I'm kind of going to go and show you what exactly this does. So I'm just making a new variable point. I'm going to set it equal to a named tuple with name point, and then it's going to have fields x, y, and z. I'm going to show how this works. Okay, so what I've just done here is I've said point is going to be equal to a new object, which is a named tuple or tuple. The name of the tuple is point, and it has fields x, y, and z. Now this looks a little weird. You might be confused. What we're going to do whenever we want to create a new point that is in the form of this named tuple is we're going to treat this like a class, and we're going to do something like this. We're going to say new p is equal to point, and then we need to give our parameters, so in this or arguments, so in this case an x, y, and z, so I'm just going to say 3, 4, 5, like so. Now you might be looking at this to be x, y, z, this is one string, this might be the name of one parameter. The way that this works, and it's actually really useful, is that it's automatically going to break up this string x, y, z into 3 different parameters. So I'm just going to print this to the screen to kind of show what I mean here. So I'm just going to print new p. And you can see that we have x equals 3, y equals 4, and z equals 5. Now what happened here is when we gave an iterable object as our different parameters, you can see that we get, it just breaks it up by a space. So I do something like gy, and then I run this here. You can see now gy is equal to 4. I can add another one on the end, like h. Oh, and then we're just missing one argument, so I'd have to add another number in here so that we get h is equal to 8. I can also do the same thing with a list per se. So if I have a list and I want all of these to be the names of it, something like x, y, and let's just do like l, and we run this. It takes 4. Okay, I keep forgetting to fix this. Anyways, you can see we get x, y, l. Any iterable object will work. I'm not exactly sure how a dictionary works, but I'm pretty sure it takes the keys. So let's just go ahead and have a look at this one. We'll just say x, 0, y, 0, z, 0. Now this might crash, but I just want to see if this actually works. Oh yeah, it does work. So it just takes the key names, ignores the values, so we get x, y, and z. And then I guess you can do the same thing with any other iterable object. Those are the only ones I can think of that are useful right now. So anyways, when we want to create a new tuple or a new name tuple, what we're going to do is just say whatever the name of that's going to be is equal to point, which we've set up here to be this type with these like parameters, attributes, and then we just give it those parameters. Now there's a lot of really cool things and methods that go along with this name tuple, and that's why it's useful. So first of all, you can do something like this: new p.x, new p.y, and new p.z, like so. And now what this is going to do is it's going to allow us to access each element by its index, so by its name, which you can't do with a regular tuple. So you see we get 3, 4, 5 to the screen like that, and we can use the same operations that we used on basic tuples. So we can do something like new p0 like that. And oops, my mod thing just popped up somewhere else, and you can see we get 3 because that's the first one that shows up. We can also print this so it looks in the form of a dictionary. So I'm just going to say underscore is dict like this. I believe this is the method, or not is, as, sorry. And when we print this to the screen, you'll see what shows up. and it says an order dictionary, and it gives us a list, and then it gives us all the tuples within, so x3, y4, z5, kind of a different form if you want to play with that and use that. We can also print out all the field names, which is useful. Say you forget the fields, you can do new p dot and then fields, and it gives us a tuple with those fields in it. The next method that we can use is the replace method. This one's pretty straightforward, but all you have to do simply is type, I don't know, let's see here, new p dot underscore replace, and just make sure you guys remember to put these underscore here. All the methods pretty well for this require an underscore. Don't ask me why, but that's the way they're written. They need an underscore. And then you're gonna put a key name. So say I want to replace y, I can say equals to 6. So we'll run that. And then if I just go here just to show you that we did change that, let's print new p like that, and you can see, oh, y did not change to 6. That's weird. Let me just see if I print this to the screen if it's gonna change. It should have worked. New p like so. Let's check. And y is not changed to 4. That's very interesting why that is not working. Okay, so I just had a quick look at the documentation, and the reason why I can't do what I'm trying to do here with this replace is because this replace doesn't actually change the tuple object. It's not capable of doing that. So what we have to do is we have to assign a new variable or a new object to that. So pretty much what this does is
Tuples are immutable, if I remember correctly in Python.
Returns a new named tuple, which we then can set to, in this case, the same name. It's going to do the same thing that we tried to do, except we just make this new p equals 2. Hope that makes sense. So now if I run the program, we can see that finally this is working. We are changing x, or I was trying to change y before, but I switched it to x to see if there was an issue there. You can see that is working like that. So anyways, that's pretty much it. I'll show one last method here if you guys are still watching. So pretty much we can do something like a new point. So say p2 is equal to points.
And if I remember, a tuple and a generator are the same thing, but I'm not really sure about that. Or maybe when you put a list instead of a square brackets and use parentheses, then it becomes a generator. Not really sure.
Hello and welcome. I'm James Murphy. In this video, we're talking about which data class solution is best for your situation. I already have a whole video explaining what data classes are, but for those of you that haven't seen that video yet, here's the gist. Throughout the process of writing code, you often create classes.
These guys' videos are really good. I really like them.
That are basically just containers for pieces of data that you've collected. It's a good thing to make these containers because they can really help people understand the meaning of your code. Take a look at this simple init function. All I want to do is store an int, a float, and a string, but here you can see that n, f, and s are repeated 3 times for each of them. This is already more repetition than I'd like, and it's only going to get worse if I want to add things like a hash function or a compare function to this class. Data classes help me get rid of all that boilerplate. Here's the same class. Notice that there's nothing repeated in the definition of the class. I only have n, f, s, and their type hints once. But this built-in data class decorator isn't the only solution that offers similar functionality. We're going to look at the different features that each solution has, and then also compare how fast they are and how much memory they use. If you're looking for the classic no-frills dependency-free solution for most cases, then just stick with the built-in data class. In my last video, the only reservation that I had about using the built-in data class decorator was that it didn't support slots. Well, I'm using Python 3.10, so now it's just this easy in order to use slots instead of an instance dictionary. The first really good alternative to data class is adders. Sometimes adders is a little bit more verbose than data classes, but it also comes with a little bit more functionality. In addition to supporting everything that data classes support, including slots, adders also supports variable conversions, data validation, and default factories specifically for mutable arguments. Here I specify a converter which is just int, so anything you pass in, it'll pass into int before storing it. There are a bunch of built-in validators like checking if something is an instance of the right type at runtime, and you can specify default arguments and default factories for mutable things. Even though you see me using data classes in most of my videos, I actually use adders more in real life. Adders just has that little bit of extra flexibility that can make a big difference in a real project. The next 3 alternatives are just based off of tuples. Whenever I talk about data classes, I always get people asking, why can't I just store this information in a tuple? Well, of course you can if you want your object to be treated like a tuple all the time. Tuples are printed in a sensible way by default, and they're really fast and they're really memory efficient. If you just want to store 3 pieces of data, then a tuple is a good choice. If you want to make your code just a little bit more readable so you don't have to access everything by index, you can use a named tuple. A named tuple from the collections library is a tuple. It's a tuple that gives names to each of its elements, and that means that in addition to accessing things by index, you can also access them by name. This is a huge win for readability. But this syntax for creating the class is a little bit cumbersome, not easy to read, and there's also no types mentioned here. If you want the exact same thing as a names tuple, but also with static type information available, then you should use names tuple from the typing library. This names tuple is a thin wrapper around the other one. It's still a tuple, and it still behaves exactly the same as the other one. The benefit, though, is that this way of defining the class is much easier to read, and it also leaves a space for the type hints. If you care about static typing at all, then you should always prefer this named tuple over the other one. The main drawbacks to using any of these data classes that are based off of tuples is that they are based off of tuples. Tuples are immutable, so you can't change any of the elements after a tuple is created. You'd have to make a copy of the tuple with a different value in one of the slots. That means you basically have to pay the cost of an instance creation every time you want to change something. The other main reservation you should have about using these tuples is type safety. You're not going to get any kind of error if you try to mix this kind of tuple and a raw untyped tuple, even if you do operations that semantically might not make sense, like using plus or less than. This is somewhat mitigated if you're actually doing static type checking, but you should still be aware. I might as well include dict in here because this is what a lot of beginners do. There's no type safety or even type information at all, and accessing things by string is really, really error prone. I know it's really convenient to write something like this, especially for testing or the first time that you're looking at a problem. But in my experience, using a dictionary this way is too error prone for my level of comfort. If this structure of having an n, f, and s is something that's going to be used many times throughout your application and not just confined to a single function, then you should really be using a class. A very slight upgrade in readability from a dictionary is to use a simple namespace. Simple namespace is just like object, except it allows you to set attributes on it at runtime, whereas object doesn't. Its use is primarily to avoid this anti-pattern where you just create a class for the sake of creating an empty class that you can put attributes on. And by popular demand, the last choice that we'll be looking at is Pydantic. Now, originally, I wasn't even going to talk about this, but in my data classes video, I got a ton of comments about Pydantic. Pydantic is a very opinionated library built for doing a specific task, parsing. By default, Pydantic will try to convert things into these types when you construct this object or set an attribute, and it will check those types at runtime. One of the common problems that you get when you're parsing data is that the data you're reading might not be valid, or it might not be in the right format, so converting things at runtime and checking types and checking conversions at runtime makes a lot of sense for the specific task of parsing. However, doing all of this at runtime is a huge waste of resources, both time and memory, if parsing is not your goal. If this data structure of an int, a float, and a string is something that's internal to my application, and my application is primarily responsible for creating these data structures and modifying them and doing whatever with them, then it would be a huge waste of resources to do runtime checking. It would be better and probably even easier to do static type checking and to catch any type errors before the program even runs. So in my mind, I don't really see Pydantic models as an alternative to data classes. They serve a very different and specific purpose. If you are doing parsing, like potentially parsing JSON from a web API, then Pydantic is a great choice. It's very good at what it does. It's just not a general purpose thing. And we're going to see that performance hit in the graphs that are coming up. Okay, time to take a step back and look at the overall picture. First up, speed. How long does it take to create an instance? How long does it take to access an attribute on the instance? And how long does it take to set an attribute? These are the creation times for each of the different classes in nanoseconds, so these are all very small. However, you can see Pydantic is losing by a lot because it's doing this runtime checking. That's a huge price to pay, so let's go ahead and zoom in on all of the rest of the things. There's a little bit of variability, but there's two pretty clear winners. Obviously, the built-in tuple and built-in dictionary get preferential treatment in the language. Tuple and dict are written primarily in C. Everything else has to go through Python. That means tuple gets to sit nicely around 30 nanoseconds, and everything else is taking about 300. If you care about this difference in performance, then you might need to be writing a C extension or just using C directly. So if you're programming in Python, I'd say that all of these should be good choices as long as each one has the features that you're looking for. All right, let's look at get and set. The first thing you should notice is that the get and set times are much less than the instance creation.
I'm gonna open your stuff. Can you tell me, can you look at this code here? Let me see. Do you think doing things like this is wrong? I'm not sure how people do this, and from what I researched in the past, they use pickle files. I never used pickle file, but using a data frame should be similar. So this function pretty much loops through the script that you created, and runs through all the folders inside of all the subfolders inside of the folder that the library is for. So, for example, here is sklearn. Then it's gonna get the file, this file here that I created, and this file contains all the subfolders on the first row of the sklearn library. Then it reads this file, it opens up, creates a count.csv file, it writes a row, and then it loops over this file here, sklearn file, using that count file to keep track of the index of the rows. And then it calls your script to create the graphs. Do you think that's a bad way to do things, or do you think it makes sense? I think I'm gonna do some push-ups there to wake up a little bit. But it feels kind of hacky to do it like that. So I'm surprised that there's not a lot of information out there on how to do these things. And then I also use this thing here to schedule every 20 seconds. Because what I think happens with GraphViz is the same thing that happens with Matplotlib when you try to save a bunch of graphs at once. It just saves one on top of the other. So you have to use subplot on Matplotlib, but GraphViz, I'm not sure if they have something similar. Because I want to find a way to create all the graphs programmatically for each folder. Because later on I'm thinking about doing something for every folder, you know, instead of just getting the imports. And then save all of them simultaneously. Because if I have to do it one by one manually, then it would take a long-ass time. So the final vision is to create graphs for all the libraries, right? And then we can change the script for what we want to get. Maybe a graph or maybe execution context or anything else. But if we have something that we can run through all the folders and then get everything, it's going to be better. Event equals call, function name equals frame.fcode. This fcode here, you're getting some attribute of the code object, right? I remember reading this in the documentation, but I already forgot exactly what it does. I think I can close this. Is about to find spec stuff. I'll look at it later. I want to understand the code first. Let me create a file for this. That's yeah. And it looks way cleaner than the other ones. I'm opening the link you sent me. So this is a debugger function. I'm gonna run it just a sec. I wanna find this stuff that I was the other methods, I think. Man, I forgot where it is now. Oh, got it later. I was looking at the other day at all the methods for finding like the under methods and these methods here. The one that you wrote there, f.code. These methods right here. The documentation on Python. But I forgot where they are. Oh, here it is. There was a list with a table. Yeah, there we go. Thanks. I just want to review the stuff you're using there. Yeah, you're using this one, right? Frame code. Code object being executed in this frame. I don't understand what is a code object really well, but and then code name as well. It's probably the name of the code object. Code name, name of the name with which this code object was defined. For key value in frame f locus items. In function name args format return trace event return. Then set trace, which is the stuff you shared here. Set the system's trace function, which allows you to implement a Python source code debugger in Python. The function is thread specific. For a debugger to support multiple threads, you must register a trace function using set trace. For each thread being debugged, or use threading set trace. Trace functions should have 3 arguments: frame event and arg frame is equal to stack frame. Call line return exception. Trace function is invoked. Then such a call, whenever new local scope is entered, it should return a reference to a local function. So I'll read this later, and so all I need to do is run. There's no arguments and anything like that. Oh, did I click debug instead of run? Created something here. I don't know what, but let me try again. Have I clicked on the debug? No. Right. So maybe it's the console. Oh. So let me rename the file. Okay. There we go. Oh, I didn't know that. So what is this? Bar equals Satan. Oh, code should trace. So I need to pass an argument here. The trace of the execution. So let me think. So this is meant to be ran as a script, right? Then I need to put here. So you're calling bar here, and then it calls here, and this is the main function, right? Is this part supposed to be part of this function, or is meant to be outside? Very, very interesting. is called by Python when any other function is called. Uh, uh. But these are just arbitrary things you built to show the print statements, right? The main function is this one and then this one. So I can erase all this stuff here, right? What are these arguments supposed to be? Event is probably the what is happening right now. Args I don't understand. Code that we are logging so you can change it. Yeah, what I wanna do is run this as a script on another file. So I wanna use this file, for example, or this one. When I run this file, I wanna run the script to show me the execution, you know? Yeah, but what arguments do I put here as a default? So I have something that runs here. Because you can't leave it blank. What do you think would be good default arguments for this? Empty string or other type? List? But it doesn't run if I don't put anything. That's the problem. Oh, it did run. No. It did run? Yeah, I know, but I'm telling here on under if name equals main. There's nothing I need to do. Yeah, right. So which file I'm gonna use? Here. Let me create a new file. Maybe this one. I think I'm gonna create a new one. In which function can I? AI tester. Or maybe neural network is too hard of an example. Do you have some code that we can test, like, but not really, not something basic, something that involves different libraries? It has to be something complex. To see if can. Oh, okay, this one works. So there's some issues here. Maybe this. I think I'm gonna erase this stuff. Yeah, because there's a lot of stuff here that is wrong, right? I just want to see what happens when I have a very complicated thing and I try to run your file on it. Because if I can only put the stuff that I'm gonna run here on below name equals main and run it on this file, then it's not gonna be enough. And now this should run. Let me see. So where do I call this? I call it at the end of the file. I wrap it around. Mm. So I have to import the file here. I can use os.py. Yes, probably some issue with the file that I'm running. At least showing some things here. Yeah, but that's not quite what I want. It's good to know though, this system set trace. System set trace. Maybe this is more useful. Can I use a decorator here? Sure. I was gonna write main here, but it seems like it's a decorator. If I do like main, does it work? No, doesn't work. Let's see, class map. Yeah, whatever. Circular imports. Yeah, now it works. Huh. Yeah, I was doing a cyclical import there. That's why it didn't work. Shutdown, stop, main thread, demo, return false, return on, return on. Destroy all, MPL, disconnect. This is already really interesting. Must be called before the code you want to debug. So it should run in the beginning of the file. But I'm also thinking about let me do this first and then I'll yeah, now it doesn't work. Oh. So maybe it did work. So it's breaking at some point here on the plot. Your object has no attribute p box. I think the first line is showing is this one, and it's not showing these lines here. So it's close, but not quite. And the other thing that I'm thinking about is that, but then this I'm not sure what it's gonna involve. Like the vision that I have is something that it lets you jump and travel with the code, you know? But then that would be the second step. The first step is to create the right framework. Then after that you can create the stuff. Oh, there's already something like this? Yeah, maybe there is, I just don't know. Yeah, so I'm gonna study that. Let me show you something, and then you can tell me if it's similar or completely different. You probably know about this, but just to show you kind of what I want to get. So it's kind of like this thing. Have you seen this? No, I'm not sure. I think it's um, uh, hello. So it's kind of something like this that I want. But instead of showing like this, showing the files, you know, on the pie chart. For example, on the first step here, where it creates the global frame, then it shows where it's getting each thing that is necessary to create the code that is running. So I can press a button and go to the file. The same thing built in and much more powerful than that website. Oh, really? Oh, damn. So I should search for a debugger. Yeah, it makes sense that people would do that because it's quite obvious. Exactly that. Even the free version. Huh. Great.
creation times. But that doesn't mean that you shouldn't worry about them. We often get and set attributes of a single object many times, so these little times can add up. Here's the picture for getting attributes. Basically, everything takes the same amount of time except simple namespace and Pydantic. It's a similar story for setting attributes. Let's go ahead and zoom in so that Pydantic isn't
Oh,
dominating
so
everything.
it's here.
Here, everything that's mutable, of course, is taking about the same amount of time. You can still choose to use an immutable thing even if you want to make changes to the objects. Just remember that if you do that, then whenever you want to make a change, then you actually pay the creation cost, not the set cost. That's because you basically have to create a new object that has the changed data in it. So unless the changes that you're making are extremely infrequent, or if you're using a raw tuple whose creation time is just that low, then you should probably just prefer to use something that's mutable in the first place. On to memory usage. Everything is in bytes and lower is better. Everything that used less than 200 bytes is something that is tuple or slot spaced. Everything that took more than 200 bytes used an instance dictionary. If you're programming in Python, you're probably not too memory constrained. But if you're really creating a lot of objects, sometimes it can be useful to save a factor of 2. This is a big place where adders and data classes shine. You can
Do you know this stuff? How did you learn it? What's the best way to learn this?
choose to use slots if you want to conserve that extra memory, or you can choose to have the convenience of an instance dictionary. Finally, here's the feature matrix to help you decide which one is right for you. In my opinion, the best overall choice is adders. The most convenient choice is data class, and the best choice for record-like data is the capital named tuple. Of course, if your task is specifically parsing, then use Pydantic. That's all I've got. Thank you for watching.
If they do have that, then instead of creating the script, we can just use that to create the graphs. Because it's the same thing, pretty much. It's not really about memory. It's just I want to visualize the execution of code, right? It's more about connection than memory. Because you can deconstruct things. To create a graph, you need to make it from scratch. Yeah, I just need to understand how this debugger works. As if it works the way that you're saying, then I don't see why it's not possible to create the same framework to create a graph. Just copy the way that it works. And then instead of showing the execution, you just create the graph with the path of the execution. Then you have the graph and the execution scope. I wish. Oh, I think I have some code here. But, wait a minute. I think I have code of the neural network from Kaggle. Or maybe I can get new ones from Kaggle. Maybe we can see it, but we can reverse engineer. I don't want to copy the stuff they're doing. I just want to use it in an efficient way. I'm not sure if that's. I don't see why that would be illegal. It's just if you're able to reverse engineer something with free resources as long as you don't copy it and try to sell it. To do the same way, pretty much anyone can do that. There's nothing that stops you from learning stuff. I think I'm gonna get code from Kaggle as well instead of getting my own, just to test this stuff. No, really? I mean, anybody can build a website, like Twitch, for example, or Facebook, but that doesn't mean that you can. Like, how are we gonna protect people from creating the same website? You know? Yeah, I don't know about that. Because the issue is on the way that you use the thing. If you're gonna take the exactly the same code and then use it is one thing, but if you wanna just use it as a tool to study, I don't see why that is. Hmm. I don't know. I don't know. In theory, it should be possible to reverse engineer everything. Yeah, but you don't need to get this stuff, right? You just need to know how it works. Because I'm not trying to copy it. I'm just trying to understand how it works. Like I'm not. It's kind of like a car. I'm not trying to. Imagine I buy a car and I want to build my own car. I'm not trying to build exactly the same car. I'm just trying to understand how the engine works, and then create my own engine. So even if I don't have access to the engine, I can look at the outside stuff and the effects that it has, and make assumptions about what's happening underneath the curtains. Obviously, extremely hard to do, but my goal at least is learning, so I don't really care. To look at the open source debuggers. It is using systrace. I wish they did everything in one file. Close. How do I close this thing? Hopefully this works just to test stuff. The last part I'm not gonna copy.
Hi everyone, in this video we want to talk about how to work with PyCharm debugger tool, or let's say PyCharm
no.
debug and Python.
I closed the zombie stuff. Oh, here it is.
Programming language. So please stay tuned. So let's go to the first example, and remember we are going to cover about 4 or 5 examples in order to explain PyCharm debug. So this is the first example. So first of all, let's define a couple of variables. For example, a equals to b equals to 2, c equals to 3, and after that we want to print the c variable, which is 3. In order to debug this code, we should put a breakpoint. For example, suppose that I want to put a breakpoint here, and maybe you ask, what do I mean by a breakpoint? I mean, for example, here I have put a breakpoint at line 5. It means that we are going to run the earlier codes, but the running process is going to stop, is going to break at this point. So this is called a breakpoint. And for example, maybe from this line to the end of the code, we want to, let's say, run the code line by line. So this is a breakpoint which stops the running process at this point. But maybe you ask, how can I put a breakpoint?
I didn't want you to learn this because it seems like a waste of time, but I guess I have to. It's just not really exciting.
Suppose that I want to put a breakpoint here, in line 5. In order to do so, we should click on this gutter. This gray margin here is called gutter. It is called gutter. It is called gutter. So this is the gutter, and if I want to put a breakpoint in this line, in line 5, I should click on this place in the gutter. I should simply click on it, and you can see that a red point, which is the breakpoint, appears. And if I click on it again, you can see that it disappears. If you understand the breakpoint concept, so click debug code 0. The breakpoint until the end of the code, it is on the verge of, console. So you can see that this is the console tab, and this is the debugger tab. Numbers between 1 and 3. In order to do so, we define a variable called, let's say, a, which we assign 1 to this variable, a equals to 1, and we define another.
Many never use them. Do you want to say I'm totally guilty of this? Yeah, it's kind of like this thing. I don't know why. It's just every time I just use the print statement, it seems like just that I don't really understand it. Like, you open this thing and then it seems like, I don't know. There are a bunch of things here. Yeah, I guess it's just the initial barrier of having to accept that you're not learning technically anything new. You're just learning how to review what you know. And it's not as exciting as building stuff. But my guess is that most people just use print statements, even very good programmers. Probably. Well, print just gives you the info you told it should be. Told it should be for running. The debugger can select what you want to see while the script is running. Oh, this is another file. How did you learn this? Are you good with using this? What would you suggest is the best way to learn? To watch videos or to maybe read articles? Oh, which one do you use? A paid one or free? Oh, Visual Studio. Mm. Yeah, there's that as well. Each IDE is gonna have a different debugger. It's also a problem. Command line debuggers. I suck at the command line as well. There are not a lot of videos that teach command line, aside from the basic stuff. I wanted to learn how to do as many things on the keyboard as possible because it seems like it become more efficient, but I think it only comes with practice, probably. Not forcing yourself to do it when you think you need it. Linux, yeah, probably. Full keyboard mode. Vim, what is that? Is that ID? But I would not recommend it. And why don't you recommend? I just want to maximize efficiency as much as I can. And I know I should be doing probably should be doing some things that I'm not doing now. So it's just a matter of clarifying what's the best path. Oh, without mouse support, then it's kind of questionable. This doesn't look like the right thing. So it's probably this one. Oh, it's probably not this one as well. Nelving. Oh. Is it free? I wish there was some way to train coding, kind of like you go to the gym, you know, where every day you can do some routine, and you can gain better recognition. It seems like that would be really useful. Maybe there are sites for that, but I'm just not aware of them. Coding game. Free and runs on the command line. This looks really interesting. I think I'm gonna download this and I'm gonna watch videos about it. And are the commands specific for the Vim, or they are commands that work on the command line as well? Maybe I should be using Linux as well. So create a machine, virtual machine, and go full on to the other side. Go to the dark side of the force. It's a game to improve your coding efficiency. Damn, that's really cool. But is it pay? Let's see. Yeah, that's the issue with these things. Like, most of the good stuff are paid resource. It's free? Nice. Oh, thanks for sharing that, man. I appreciate it. WSL. Erase other players. Sounds fun. Hmm. But it's kind of like a typing race thing. I guess GitHub Copilot is kind of what I was thinking about. But instead of having the suggestion, you just create the code yourself. For example, you have a bunch of code from Stack Overflow, let's say, or from other places, and you just practice doing that, you know. But not only not only typing, but building the thing, something like that, where it's very simple, but it trains you to remember the repetitive stuff and to understand how the methods work. So how to build a class, for example, instead of having to think about, oh, what project do I have? What project can I do to incorporate a class so I learn it? I have a site that takes you step by step, kind of like a free code camp stuff. The free code camp courses are very good for JavaScript. It's something like that I was looking for. Ways to solve a programming task. Sum all even numbers in the input. They're not that simple. Oh, sounds cool. It's called WS Challenge Coding. Now let me read this one that you shared.
And how it works is a group of people are all given a problem at the same time, and they have to
Windows subsystem for Linux. Yeah, but if I go the Linux route, I'm not gonna use Windows anymore. I actually don't like Windows that much. I just don't go through. Not Linux. I don't like Windows that much. I just don't go to Linux out of laziness, I guess. Because I hate the fact that they force you to update. I really don't like that. Yeah, it kind of sucks. But then Linux, you have to think about every time you're gonna use something. It's like a hustle. You have to figure out how to do it and spend a bunch of time. But it's probably like that only in the beginning as well. You probably after you get used to it, it's better. But maybe I'll make the change eventually. Arc, but I would recommend Ubuntu or Mint for beginners. Yeah, I installed Ubuntu once. Maybe I'll do it again. You have to download the virtual machine, right? Kali Linux. Yeah, that's was the stuff that I didn't like. So every time I need to open that, and then I need to allow the transition from the virtual to the thing. So maybe I have to make the full change of the operational system of the main machine to Linux. But that's gonna take a lot of work.
Solve it in one of 3 modes. So
yeah, but then I have to boot the system, and then I have to. It's a lot of work. I'm not sure if I'm gonna do that. If I'm being honest. I think I probably should, but I think I'm gonna wait a bit. At least 1 year or 2, when I'm a lot better. But it's risky, right? Like maybe I fuck something up, and then what I'm gonna do? You know what I mean? I need to have some money saved in case something goes wrong. I can fix it.
the mode is selected at the beginning of the round, and it's going to be either fastest, shortest, or reverse. In fastest mode, we have to find the solution as fast as possible. In shortest mode, we have to code up a solution using as few characters as possible. And in reverse mode, they just show you the inputs and the outputs, and you have to figure out a function that maps those inputs to those outputs. Let me just show you how it works. So before working at Google, when I was practicing for the coding interview, this is one of the things I would do. I'd play coding games online, and you kind of get used to working under pressure, and you also can learn from other people's code when you look at their solutions.
Yeah, I have an external hard drive. I can do that, no problem.
Reverse mode. All right, so given 5 and 2, the output is 2. Looks like we have to output the lowest answer. If m is less than n, print m, else print n.
But this stuff seems really good. And if it really is free, I'm probably gonna do this every day before I even do anything else.
Boom. The W. All right, that one was pretty easy. Usually they're a little harder than that. Let's try it again. All right, here we go.
And I definitely should download
All right,
this
mode
as well.
fastest. Your program must output the facial composite of a wanted criminal from the description of a witness given to you in the form of ASCII characters. The description consists of 1 character for the hair, 1 character for the size of the face, 1 character for the eyes, 1 character for the nose, 1 for the mouth, a string of 1, 2, 3, or 5 characters for the chin. Each item separated by a space. Do not include a trailing white space after the chin. Input string. Hair, cheek, eyes, nose, mouth, chin. Composite of 5 lines and 5 columns. The chin must be centered. So, let's go. Print hair times 5. Print. We're going to call this cheek C. C plus chin must be centered. Oh. Can't multiply sequence by non-int of type float. Oh, don't include trailing space after the chin. Okay, that's it. Okay, got it. Let's submit it. Whoo! That was... We created a guy's face. I don't know if this is the best coding practice, but it's kind of fun. Let's battle again. Got another W under the belt. Shortest mode. The program must output the input word after shifting its letters. Letters whose index would be negative are placed at the end of the word. The shift amount can be greater than the length of the word. In that case, it loops. So we're given n and word, and we have to shift word to the left by n. That should be easy enough. So we'll divide n by the length of the word and get the remainder. And we'll print word n plus word 2n. So this will print the last part of the word, and this will print the first part of the word. And it works. So now we got to try to reduce it down to as few characters as possible. I think that's my solution. I'm gonna go for it. See how it does. So far, it's the best solution. All right, so we ended up winning that one as well. Let's go again. All right, we got a shortest mode. Here we go. Call a number num strange if there is such a number x. So if you perform the operation x to the power of x plus x, you will get num. In the problem, you must check if a number is strange. So the num will be within 2 to the 32. So what's 2 to the 32 to the 0.5? All right, so we have to go through 65,000 numbers. Process has timed out. That's taking too long. Let's try if num divisible by x. Continue. So that should work. All right, we got the code down to 73.
This section here, right? Single players. Is any language? You can use any language, or can you train specific languages? Do the challenges involve classes and like doing specific stuff, like decorators and stuff like that? I think I'm gonna install this through here with the Choco stuff. So I have to run from the PowerShell. Just in case, I'm gonna do this temporarily, because I'm not sure if I can show you stuff. Now being you can solve them the way you want in any language you want. They do have tags that show what concepts you will most likely use to solve it. Nice. Yeah, I think there is no problem in showing this stuff. What did you do to become good? You seem to do things very fast. Like what takes me even a couple of days, you did like probably in a few hours or less. The script that you did there would probably take me a few days to do it, or yeah, maybe I could do it in one day, but yeah. But how do you practice? You just build stuff, or do you do sites like this? What's the stuff that you do the most frequently, and that you think that it was the best for you to learn, or to become good?
I'm gonna see if I can get it even smaller. All right, guys, I got it down as small as I can get it. 69 characters. What it's basically doing is looping through X.
I think the
So I thought
basic
maybe
stuff I got down already. Like I don't really need to think about it anymore. To create for loops and if statements and to open data frames. I'm getting better with time on those things, but the more complex stuff, I struggle a lot of thinking about ways to incorporate that, because it's difficult to know what is the right time to do each thing. Some stuff I learned from videos, some I learned from other people, code, from reading docs, some I learned by just trying. Yeah, seems like about right. I'll probably have just sign up. Now I'm gonna do this, and then I'm gonna create an account here. And this stuff. Just to see how it works. So I usually have an email just for this type of stuff. Let me see. The one thing I remember specifically was a YouTube series that really helped classes click for me. Can you share it? That would be really, really dope. I think I do need some practice though. That's the problem. Just watching videos is not gonna. Because the concepts, I think I understand everything already on the concepts. Oh, this guy is really good. He explains things really well. Corey. And I watched a bunch of videos about him already. Yeah, I already watched this videos. Do you know C++? Hmm. I'm probably gonna speak Python 3 for now and C++ later. Hmm. Yeah, JS is easier than the other ones. It's all the same shit, honestly. That's all your program. Except C++ and C, which are the hardest ones. The rest is just probably all the same. With few exceptions on methods, but the overall structure is the same. Start a program to shoot the closest alien. Copy and paste. Maybe I've seen this somewhere. Yeah, it depends on what they think professional coder is. What nickname should I put here? Usually I go with points just because it's the easiest one to remember. I think I'll think about it a little bit more. So where is this stuff installed? It doesn't show up. That's weird. It says that it is installed, but I tried, it didn't work. It's probably somewhere. It must be somewhere. Maybe it's the nvim. Or maybe there is a different command that I need to run. Yeah, now it works. So let me see. Yeah, but this doesn't work. Which is weird. Oh, sorry, there's just the command line? There's no user interface? Alright, that's gonna be tough to use, not gonna lie. So you just code everything from the command line. Damn. But how do you do files? How do you do multiple files? What? I don't know what I wanna do, I just wanna understand how it works. Yeah, it seems like this is gonna be too difficult. Oh, it shows up on the bottom here. So I have to put 2 dots before. Does this help you become good at the command line? Like, is the same? Does it work the same way that the command line does? Hmm. Oh, so it's probably not very good for me. Yeah. No, it's good to know, so I'm probably not gonna use it. So let me think about the username. Or I can put the Twitch thing. It's probably a good idea. In the future, we recommend learning the basics of Thing, because if you use somebody else's Linux computer, it will most likely have been installed. But I think that's more like, doesn't seem like it is something that's really fundamental. It's more like if you already know a bunch of stuff, then you learn it. I was thinking more about using it to train the command line stuff, but since you said that's not the same, I don't think it's gonna be worth it. SSH into a machine remotely, that only editors you have are Nano and Vim. What do you mean? How is number 24? I mean day. Also, this doesn't matter probably. Oh, I thought it was Vivex. But what do you mean about day 24? No, I'm not really sure. Do you mean coding? Those days that I was doing it was for C++, not for coding in general. I think on coding I'm probably on day around I don't know, 200 and something. C++ I stopped temporarily to learn some stuff. To learn AI. To learn how the AI works, so I can build a basic one with the libraries that I have. Then Vivex helped me build some stuff to visualize libraries. And then he showed me all this stuff here that I'm checking out right now. Yeah, but this is the first page. Let's start on the beginner ones. You studying Python so you can test my code? No, I'm studying to learn AI. to implement a basic AI network. Your code is true advanced, man. That one is shared. Is a game, right? Roblox. So here's the task. If the loop, read the heights of the mountain from the center input. And the output index of the mantra. AI challenges on the site. Oh, that sounds really, really interesting. I might have to check that out. I just want to understand how the things work first. So I guess here I put the code, then I put the tests here. It's very similar to Code Camp actually. Let me see if I just also now. So when I pass here, it displays what's happening. Minus 14 tonight. What do you mean by that? So at the start of each game, you're given the height of the 8 mountains from the left to right. 0 to 6. By the end of the game, you must fire on the highest mountain by outputting its index from 0 to 7. So I need to print the index of the mountain to shoot. The while loop represents the game, each iteration represents a turn of the game, where you are given the inputs, the heights of the mountain, and where you have to print an output, the index of the mountain to shoot on. The inputs you are given are automatically updated according to your last action. I'm not really sure if I understand what I need to do, but I don't know. Oh, it works? So here's the output I get, I guess. Not really sure. Oh, so I need to get the highest value of the inputs, which are stored on mountain H. So I need to compare them. Maybe I can use string value there. So it doesn't work. Oh, I need to put this outside of the loop. I don't know if I can do that. But should be an integer from 0 to 7. Did it work now? Probably not. Hmm. Oh, so now it's showing me the three things. Maybe the print statement needs to be inside. But here it says the index of the mountain trail. Write an action using print should debug. Represents the height of one mountain. destroy the mountains before your starship collides with one of them. For that, shoot the highest mountain on your path. So the ship goes from here to here. These are the mountains. Okay. The start of each game turn, you're given the height of the 8 mountains from left to right. By the end of the game turn, you must fire the highest mountain by outputting its index from 0 to 7. Firing on a mountain will only destroy part of it, reducing its height. Your ship descends after each pass. Within an infinite loop, read the heights of the mountain from the standard input and print to the standard output the index of the mountain to shoot. The index, not its height. So the input is the height, not the index. Oh. So maybe I need to append the inputs on a list and then get the index of the highest one. Is there any specific thing about where you can write code, or you can just change anything? It doesn't matter. Like, can I write something here, like import other stuff? Or I can only change inside of this for loop? For one game turn, 8 lines, one integer mountain, each per line. Each represents the height of one mountain given the order of their index from 0 to 7. Oh, so it shows up according to the index. So now I just need to figure out. Yeah, I can do just use y. I just use I mean. It doesn't work again. Oh, I have to change it here as well. Oh, maybe I don't need this actually. Yeah, I don't see what's wrong with this code. Oh, now it passes. Nice. I wonder if there are any rules for the thing. It took me a long time. I guess it's just so it's gonna take me a long time until I'm used to the way that it works. The functionality of the site. How can I close this? Maybe here? Okay. Oh, so here there's the Discord. How do I do one after the other without going through the whole thing? But damn, this is really good. And if they have stuff for our AI, it's gonna be even better. Let me think about it. I think first I'm gonna keep studying this stuff that I need to study. Then after I'm done with that, I'm gonna check this site out.
The first three things that I want
variable which is called b, and we assign 3 to this variable. So suppose that we want to print the numbers between a and b. I mean, for example, in this example, 1, 2, 3. So here we simply type for I in range of a and b plus 1. And maybe you ask why b plus 1 and not b? Because this second value, we know that in range function in Python programming language, this second value is exclusive. So if you want the numbers between a to b, we should write a and b plus 1 because this second value is exclusive. So after that, we want to print the I. And you can see that in each iteration, you can see that we are iterating over a to b, and we want to print each I, I mean each number, when we are iterating over this range of numbers. And for example, and 3 has been assigned to b variable. So the previous lines before this break, something is happening in the console. You can see that it has printed 1. I mean, it has printed I, which in the first iteration, I is equal to 1. And if I click on this step over icon, you can see now I is equal to 2, and we're going to print the I, and you can see in the console, it has printed 2. And if we
so I can use step over. It didn't work. Why is opening this other file? Doesn't make any sense. So this is the file that I was in. So this jumps from frame to frame. So I guess it's the other way around. I think I'm gonna do a simple function before I try this one. Maybe I'm gonna erase this and get a better one.
click on this step over icon, you can see that now I is equals to 3. And if I click on this step over icon, you can see that in the console it has printed 3. And if I click on this step over icon, you can see that it has finished its debugging. So let's take another example. Suppose that we want to define a function called double, and we want to pass an argument, which is x, to this function. And this function is going to return x times 2. I mean, this function is going to double the input. So for example, here, maybe I want to double 5. I want to double this number. And here I want to store the result in a variable, let's say called result. And here I want to print the result variable. So if I run the code, not debug the code, you can see that the output is 10. But maybe maybe we want to debug this code from this line until the end of the code. So after putting this breakpoint, I should right click on this page and I should click on debug code 01, which is the name of my code. So we can see that the debug panel, the debug window appears. And we can see that here we are going to step over each line of the code. For example, I click on this step over icon and you can see the double of 5 is 10 and it is assigning the result, 10, to the result variable. And here we are going to print the results variable. And here if I click on this step over icon, you can see that the console is blinking and it means that something is happening in the console and you can see that the result has been printed. But maybe you ask, how can I go inside that function, this function, and not just step over this line? How can I just step into this function and see what is happening in the function itself? In order to do so, in order to step into that function, that double function, and see what is happening inside that function, we should right click on this page and we should click on this debug code 01. And after that, you can see that the debug window appears. And here, instead of stepping over each line of the code, we should step into my code. Why? Because we want to step into that function and see what is happening inside that function. So here we can see that we have something called a step into my code. This is an icon that you can use for stepping into your code. So I should click on this icon and you can see now we are going to my function. You can see that the function is taking x as the input, which is now 5, and it is going to return x times 2, which is 10. So I should click on this icon and you can see that the result of this function is 10, which it is assigning this number to the result variable. And now we're going to print the result variable. So if I click on this one, you can see that the console is blinking. It means that something is happening in the console, and you can see that the result variable, which is 10, has been printed. So you can see that in the stepping over, you are stepping over each line of the code without going inside any function or classes or such other things. But here, when we step into my code, we are going to inside each function or each class or whatever that you want. So you can see that there is a difference between stepping over each line of the code and stepping into the code. And here, suppose that we want to print a number, a random integer number between 1 to 3. Why? Because this is an example in order to show something called a step into. So here, suppose this example that we want to generate an integer number between 1 to 3. In order to do so, we use the random package. So we can see that we have imported random package, or let's say random module, random library. These terms are used interchangeably. Module, library, package. And here, I should simply type random. I want to use this random package, and I simply type rand int. It means that I want to use the rand int function, which generates a random integer number between two numbers. I want to generate random integer number between 1 to 3, and I want to store the result in a variable, let's say called result. And here, I want to print the result. So here, if I run the code and not debug the code, you can see that the output of the second one, this result, which is the random integer number between 1 to 3, is 2. So if I run the code again, you can see now the output is different. Why? Because this is a random process. Each time you run the code, it is possible to get a different result. So here, if I run the code, you can see that we get the same output, but it is possible to get another output. Why? Because it's a random process. And if I run the code, you can see that we get 2. If I run the code, you can see that we get 3. If I run the code, you can see we get 1. So this is the thing that we want. But maybe we want to start debugging from this line of the code. And in order to do so, we right click on this page and we click on this debug. And you can see that debug window appears. So here, I should click on this step into my code, and you can see that it steps into my function. So this is a function which the input is 5, and you can see it is going to return 10. So if I click on this step into my code, you can see the result is 10, and this 10 has been assigned to a variable called result. And here we are going to print the result variable, and you can see the console is blinking. It means something is happening in the console. And here, if I click on this step into my code, you can see that we have imported random package. And here we are going to step into my code. So here, if I click on this code, but I want to step into it. For example, suppose that we have a class from another package, we have a function from another package, and we want to step into that one. Of course, that is not my code, but I want to step into that one. In order to do so, we should right click on this and again click on this debug. And here we shouldn't click on the step into my code. For example, here, if I step into my code, you can see that the result is 10, and we are printing the result variable, which is 10. But here, after printing this random package, we don't want to step into my code because this is not my code. This is a package code. This is a libraries code. So I should click on this step into and not step into my code. So if I click on this one, you can see it steps into the code of that package, and you can see that it is going to step into each line of the code in that random package. But if you want to step out of this package, we should click on this one, step out, and you can see now we are on this line in our code. And here, if I click on step into, you can see that it has generated a random integer number between 1 to 3, and it has assigned the result to a variable called result. And here we are going to print the result variable. So you can see something is happening in the console, and it has printed 2, which is that number that has been generated between 1 to 3. So here's a summary. Step over means that we are going to run the code line by line without going into any function, any class, or etc. Step into my code means that we are going to run each line of the code and going inside any function, any class, or etc., which is my code, not other modules code. Step into means that we are going to run each line of the code and also stepping into any function, any class, or etc., both in my code and other packages code. And step out is very clear. We're just stepping out. Okay, consider this example. We have defined the double function, and here we can see that we are doubling 5, and we are storing the results in a variable called a, and here we are printing a. So if I right click and click on this debug code 01, you can see that the debug tool appears. And here, if I, for example, step over this line of code, you can see now a is equals to 10. For example, I want to calculate something. For example, maybe I want to calculate what is the result of a plus 2. I know it is very simple, but this is an example. I don't want to print anything inside this code, but maybe I want to see what is the a plus 2 output. For example, let's say what is the result of a plus 2? What is the result of a divided by 2? Or such a thing like this. I don't want to print anything inside this code, but I want to see what is the output. In order to do so, I should click on this evaluate expression icon, which is like the calculator. So I click on this, and here I can type whatever I want. For example, I want to see what is the output of a plus, let's say, 3. And if I click on this evaluate button, you can see the result is 13. I mean, a is 10, and of course, a plus 3 is 13. Maybe I want to calculate 8 divided by 2, let's say. So if I click on this one, you can see the result is 5. So this evaluate expression is used to evaluate whatever you want without printing anything inside this code, without putting any code inside this code, and you can simply evaluate whatever you want inside this evaluate expression icon, which is here. Okay, let's take another example. Here we have defined a couple of variables: a equals to 1, b equals to 2, we are printing b; c equals to 3, d equals to 4, e equals to 5, and here we are printing e. And remember, we can have different breakpoints. For example, maybe I want to have a breakpoint here in line 5, and I want to have another breakpoint in line, let's say 12. There it is. And what does it mean? It means that it is going to run the previous lines before getting into this first breakpoint. So for example, if I right click and click on this debug, you can see that it has run the previous lines before the first breakpoint. You can see that a is equals to 1, and it stops at the first breakpoint. And if I want to run from this first breakpoint until the second breakpoint, I should click on this icon, which is the resume program. And if I click on this one, you can see that it runs the code from this breakpoint until the second breakpoint, and it stops at the second breakpoint. So here, for example, I can step over from this second breakpoint. So if I click on this one, you can see that it steps over this line, and it has assigned 5 to the e variable, and here we are printing the e variable, which the output is 5. So we can have multiple breakpoints because maybe we want to run a part of the code, and after that we want to go to, let's say, 10 lines later, and we don't care about these 10 lines, and we want to start running the code line by line, let's say from line 12 here. Thank you for watching. Please remember that this series on Python tutorial is going to continue, so please make sure to subscribe and click the bell next to be notified of every new video. And also, if you want to talk about Python debugger in more details, please let me know in the comments below.
Here. I think I'm gonna search for a simple
Hey there, welcome
recurrent
to
neural network in Kaggle.
Hey there, welcome to
And this is just how to install.
Hey there, how's it going, everybody? In this
Not too useful. I'm gonna go to the bathroom, Breakpoints. Let me see if what the code's here. So I'm probably gonna copy this stuff. I'm gonna copy this stuff on that file. No, but then, yeah. That's the issue, is that I'm gonna need the data set if I copy these ones. So maybe it's just better to get something. This should be good.
Video, we want to talk about how to run only parts of my Python.
Hey guys, and welcome back to another PyCharm tutorial video. In today's video, we're going to be talking all about debugging and the way that PyCharm can help you debug your code and save you a lot of time and a lot of headache while coding. So the PyCharm debug tool is extremely useful and extremely powerful. When I first found out about it, it kind of blew my mind because it was allowing me to do things that I never would have been able to do in idle and saved me tons of time. So first of all, the debug tool is up here in this top right hand corner. It's right beside the run. It looks like a little bug, which makes sense. So if you click it, it's going to bring up your basic console and it's going to run the program just like it would before. The only difference is you get this little debugger tab, and this is what I'm going to be showing you how to use today. There's a lot of cool tools in it. You can hover over some of the stuff and kind of play with it for yourself if you don't believe me. So I'm just going to end the program for right now because I want to show you how to add breakpoints first before we can really use this debug tool to its full potential. So when you're debugging code, a lot of the time, you know like where a loop is or like where a statement is that's giving you some issues. So if you want to check out that statement, you want to look closer into it, you might want to add something called a breakpoint. And this is how we're going to be doing things with the debug tools. You can see I have a little bit of code here. I have one function, two functions, and pretty much all this does is it's just going to get two random numbers and it's going to ask you to tell what the multiplication of those numbers is. If you get it correct, tells you correct. If you get incorrect, tells you incorrect, and so on. So to add a breakpoint in PyCharm, you have this thing called the gutter on the left-hand side, and you can see beside the line number. If you click, then you can add a little red dot, and to remove it, you just click on it again. So what I'm going to do is I'm just going to add one at this if statement here, and I kind of just have to show you by example how this works. So when I start running the function, just notice it's going to run this main function 10 times. When I run, we're going to go in this while loop, it's going to ask me a question, and then it's going to check if this is a digit. So let's just run this in the debug tool and see what happens. Okay, so I'm clicking debug. It asks me to type in a number. So we're not yet at this line because we're still asking for input. So let's type in something. Let's type 56. And now you can see that my console moves to the side and we get into this debug tab. What this breakpoint does is it breaks the execution of the program at this point. So the second we hit this if statement, we're no longer executing, we're stopping and we're having a look at this statement. So you can see on the right hand side, it shows me a bunch of variables and then it shows me these frames here. So let's talk about the variables first. So whenever you have a breakpoint, when you hit that breakpoint, it's going to show you all of the different variables and so on within that scope. And the scope right now is this main function. So you can see I have the variable run, I have num, num2, result. Now look at my actual code. It shows me with a little comment beside each variable what those variables are equal to. And this is actually amazing. I don't know how this even works, but it can save you so much time, especially if you're messing around and you actually have a variable that's resulting in none or something like that. So you don't have to keep printing them to the screen. It just shows you them right here. So you can see ant equals 56, result 6 like this, and it shows you the same thing here. Now I want to show you, we can actually add new things to look at as well. So say we want to just look at the variables, that's great, and this is going to save us a lot of time. But what if we want to check like an expression? So we can actually use this thing called new watch. So I'm going to click new watch, and in here I'm simply just going to type an expression. In this case I want to say if string ans, is equal to, and in this case we're going to say, what is it, result, like that, okay? And then I'm going to click enter, and you can see this gives us a result, and it says false. So it says if the string answer is equal to result, and then it's just going to give us the answer to that expression pretty much, or whatever that value would do. And we can add as many as we want. We could do something like ans plus h, and now you can see I get 56h. And you can do whatever you want here, you can make them as long as you want, and that's why you can look at different expressions without actually having to have them typed out in your code. The delete one, you can click the little minus key, it deletes it, same thing here, and add new ones, again, just click new watch. Now I'm going to talk about these frames in just a second, but let's go back to the console for 1 second. So I've asked what is 3 times 2, 56. We've looked in our debug, we've seen, okay, all this looks good. We want to continue running our program now. You can see we're still running, we haven't stopped the program. We just took a break at this breakpoint. So to continue running the program, we click this little icon here, and it's just a little, the play button with a little line through it. So resume program. So we'll resume program, and now we'll resume and we'll rerun everything until we hit the breakpoint again. So we've run main again. We've now printed another thing saying what is this value. So it's 3 times 2 again. So let's just type, I don't know, 5. Okay, now we've hit the breakpoint. Same thing happens. We can go back to the debugger.
I'm gonna try Yeah, but this doesn't show anything when the program is asking for inputs.
console, we can see that ANS equals 5, num, result, and so on. Again, if we want to run one more time, we click run. What is 3 times 2? Just because these aren't changing, don't worry about that. We do 6. Okay, if we hit the breakpoint, same thing, go back to debug, and we can see all these values like that. Okay, so when we want to stop the program,
Maybe I should put a breakpoint here. It doesn't show anything. Oh, now it shows. So it's showing there. But when I click here, it disappears. So we go again. So much stuff to learn. I think before I continue with this, I'm just gonna watch the videos.
we can just click stop debug.
I need to finish this thing first, just so I can get out of my mind.
And there we are. Now you can actually add
And
multiple
study the syspath stuff, the import lib.
breakpoints as well. So if you wanted to break, first of all, at result, see what's happening there, and then you want to resume and break at the else, that's perfectly viable, and you're allowed to do that. Okay, so let's just add another breakpoint. This time I want to add it at this random.randint. So whenever we call this, I believe it's going to break here. Okay, so let's run the program again in debug mode. And there we go. Right away, we've hit this breakpoint. That's because we're calling main. We go num1 equals generate random number. And there we are. So our upper limit in this function is equal to 10. And that's the only variable that we have so far. So if we want to see the value of r, well, we would have to break at return r because we haven't actually yet set that variable because we haven't executed. But I want to show you what these do up here. So we have a step over, step in, step into my code, and step out, and then step or return in some cases. But in a lot of times, we don't want to step into the program. So step into my code. If we want to step into this while loop, we'll click step into my over. We go to correct, keep going, and I can keep stepping, and we go back into this while loop like so. So pretty much, you're going to have to play with these because they are hard to kind of explain how they all work. But once you get the hang of these, they'll save you a lot of time in debugging your code. Now, there's one more thing I want to show. So I'm going to just add another breakpoint in, I don't know, return r here, okay? So we're going to run debug. We're going to be brought into here, and you can see we have the variable r and upper. Now, I want to show you this thing, and it's called evaluate expression. So it looks like a little calculator here. If you click evaluate expression, you're actually able to evaluate any expression with the variables that are in the current scope. So the ones that are showing up here. So I do something like r plus 7, you can see I get a result of 17. I could do like string r. like that, and it gives me a result of 10. And you can evaluate any expressions you want without actually having to type them in your code. Again, this will save you a lot of time, and it's extremely useful if you don't want to be constantly printing things out and typing them in here, because in idle, to be able to do this, you'd have to print string R, and you'd have to print like the type of it, whereas right here it gives you the exact value and even the type, which is really useful. So now I told you I was going to talk about frames, so let's do that here. So in these frames, we have multiple. So we have a main frame, which is, well, this function main. We have module, which is just anything that's within like the least indentation level, so in our main line here, so this stuff would be in the debug frame. And we have generate random, which is a frame for this function. So we can check into multiple frames whenever we're kind of looking here. So since we broke here before, we were able to create any more variables and create result. If I step into the main debug frame here, then it only gives me a variable of run, because we haven't created num1 yet, we haven't created num2 yet, we haven't created result, so you can only see that one. If I step into generate random, you can see that I have the variable r and the variable upper, and then same thing if I go back to the main one, we have x in time. So you can step through these frames and look at what's exactly happening in every function, every method, so on. So again, if I want to resume, I'll resume, and now if I go back to the main, you can see that we have num1 is created because we've just stepped through another iteration until we hit this breakpoint. So I'll do so again, and you can see that our program just continues, because now that we've called generate random twice, we're never going to hit this breakpoint again. Okay, so I think that's been it kind of for debugging. There is more things that you can do, but this is kind of the basics, and this will save you a lot of time if you can figure it out.
Hello
I
everyone,
recommend practicing
and
on
welcome
how
back
this
to the
debug thing works and kind of just playing around with it with some of your own
so
code,
in
putting some
today's
breakpoints
video,
places,
what
seeing
I'm
how it
going
works,
to be
because that's
doing
really the
is
only
teaching you how to use a debugger. Now I'll be using the VS Code debugger here, and I'll be working in a Python script, but don't worry, this video will apply to any debugger for any development environment that you use, and if you're not sure what a debugger is or where you even access it, you'll need to be using an IDE to get access to a debugger. There's some tools that aren't IDEs that have it, but in most cases an IDE, which is an integrated development environment, will come with some kind of debugging tool, and that debugging tool will look very similar to the one I'm about to show you here, and will definitely have the same 4 or 5 commands that I'm going to be aiming to teach you about how they work. So with that being said, let's go ahead and get started. Now, what is a debugger? A debugger is really a tool to help you look at what's going on in your program. Usually when people are debugging, what they'll do is they'll do something called print debugging. So if you've never seen a debugger before, you're not using some fancy tool or environment, your way of probably checking what's going on is printing things out to the console or printing things to your terminal or wherever you're running your program. So you might do that by just going in here and say, okay, well, I want to print what numbers is, just have a look at that here and see if things are what I expect them to be. That's totally fine. You can do that. And for simple programs and for simple scripts and whatever you have, that's totally fine. And I do that all the time as well. But as soon as you get into something that's pretty complicated, where you might not know the values you actually want to look at, maybe there's a lot of files, there's a lot of different states that you want to examine, it can get really messy if you're just printing values out into the console. So instead, you use a tool like a debugger. Now, right here, I actually have my debugger active. It's currently running, and I'll explain what all of this is doing later. But you can see that I'm actually able to look at all of the different values in my program. So I have a breakpoint right here, which essentially tells the debugger, hey, I want to stop, pause, and have a look at what's going on at this point in time on line 25, the one that's highlighted yellow. On the left-hand side here, you can see that it shows me locals and globals. I can click into these, and I can actually have a look at all of the variables that are associated with the current scope that I'm in. So here, for example, average is a variable that stores the kind of pointer to this function right here. Generate numbers, oh, well, that's a variable that stores the pointer to this function right here.
Eat something. Let's see what time it is.
Highest running average, same thing. Random, oh, what's that? That's the variable associated with this import. So you can actually go in and look at all of the different values associated with each of these variables. Now in this case, it's not super useful because these are just functions, but I will show you throughout this video, of course, how we can look at actual code and not just function pointers and all of that. But this is just to give you an idea of what a debugger can really do. So you place these little breakpoints, which I'll show you how to do again, and then what you can do is use some of the commands that are up here in this menu bar that I'm moving around, which I'm going to leave up here, to actually step and navigate through your code. So there's 3 main tools here that you want to know how to use. Step over, step into, and step out of. Now they each have shortcuts. You can see the keyboard shortcuts right here. I'm going to be showing you how to use these, but I just want to, again, give you an example of what they can actually do. So look here when I click step over. What this does is actually move this little pointer here to the next line of code.
Oh, this is for VS Code.
So you can see that now what I actually have is a variable called nums that stores all of the nums that were generated from this line. So I can actually go ahead and have a look at what all of these different numbers are. I can see the properties, for example, the length of that list, so there's 100 different numbers, and anything else that's related to nums. I can go ahead and I can actually look at that, which is great. What I can do next is I can step over again. So I can step over that line right here. Nothing's changed because I haven't updated any variables or anything into the scope. And then what I could do is actually step out of, and what that will do is take me outside of the current scope, which in this case will end the program. So now that I've given you a little bit of an example, let's go into some more detail and show how we can really use this debugger effectively. Here, and it shows me where they are by line number, and I can simply deactivate them by just unchecking that button. It will erase it out, and what that means is I'm not going to remove that breakpoint, but I just want you to ignore it for now. It's almost like commenting the breakpoint out if you want to think of it like that. So once you're ready to actually run your code, you can click run and debug. It's going to be different in whatever environment. In this case, you have to select what file you want, so I'll click Python file. Here, we go ahead and we start debugging, and then we hit the most recent breakpoint, and then here we are. Now, the other 2 features that I kind of want to discuss here is this watch pane and this call stack. So I won't be using these in the examples because we don't really need to, but say there's a certain expression that you want to watch, or say there's a certain value you want to look at that isn't directly written inside tools that you want to look at. I type in here, so I can a little bit. So there's different ways to place breakpoints.
Maybe an interesting thing to look at is how to code the debugger. That seems interesting. Yeah, so obviously most videos are gonna be about the debugger, not how to build one. I guess I'll look at that later.
Hey there.
Jesus.
Hey everybody, what is going on? Welcome to another Python tutorial. Sorry it's been a little bit since I put out a pure Python tutorial. It's been about a couple weeks. I've been super busy with algo and automated trading of Bitcoin. I actually already have one investor and another one who's interested. That's been going really well and we've been having some great results there. So naturally a lot of my attention and focus has kind of gone that way. Plus we had the holidays. Things have just been pretty busy. So hopefully you guys all had or are still having some great holidays. Also, I do have a gift for you guys. And this one actually comes from someone named Igor Vasilshikov. Sorry if I mispronounced your name. I don't think he'll be watching this video anyways, but yes, it comes from him. Looks like he actually works for EMC Corp, which is pretty much the definition of big data. So it's fitting he passed us some pretty great information on what we're going to be talking about today, which is buffering. So all of the videos and quote-unquote big data videos that I've ever put on here are all really considering file sizes that a single computer's amount of RAM is going to be able to handle. So most of like the data files that I use that I consider big are better put probably large. Maybe 3 gigs is pretty much the biggest one I've ever really messed around with, and that's 3 gigs is a pretty nice stock output file. That's your tick data right there. So the question though is, how would you open up a file that is far greater than your RAM, right? So let's say 100 gigabytes or a terabyte, or also how should you open up a file that's 2 gigabytes even? So without because you don't have to read the whole file into memory. So even if you don't have like a huge file, you can at least save some memory by not reading literally everything into memory immediately. So far, only really one video in the series with machine learning, the one where we did the pattern recognition. That was the only video that really required that we use the full amount of data to be read into memory, since it referenced all of the data constantly to like make all of the patterns. But you wouldn't necessarily have to reference all of the data either. We just chose to. But most of the time, you should be able to read like a large amount of data into memory in chunks, right, to make any of the changes that you need to make or perform analysis or whatever. So to do this, we utilize buffering. So what is buffering? Well, the idea of buffering is to like ration the amount of input from a source. So you can think of it like in a day, you might be able to eat 2,500 calories, but you wouldn't be able to consume that much in one sitting, or you shouldn't be able to. Some people can. Anyway, you shouldn't be able to. You have to buffer, right, and eat maybe 500 here, 750 there, etc. Right? Your computer's the same, so it just kind of makes sense to do this buffering, right? So you wouldn't, that's back to the food example. You wouldn't open up the fridge and take out all of the food at once. You can't possibly eat all of the food. So why would you take it all out at once? Because you're just gonna put it all back because you're not gonna be able to even reference that, So that's where the buffering comes in, right? You open the fridge, which gives you access to make, let's say 15 sandwiches, but you just grab the stuff necessary for one sandwich. You make one sandwich, and then when you're done consuming and digesting one of those sandwiches, you're set to do another one, right? So let's do that with programming and opening up of a file. So what I've got here is a couple of files. I'll just show them to you guys. We have a file I've called Big Datas, and it is 50 gigabytes, so just a little bit more than my RAM. I've got 16 gigs of RAM here. Here we go, total and installed here.
I think I'm gonna make something to eat and eat while I watch this
And I'll bring this over when we start reading it, because in theory, well, we would max out our RAM, but I'll also show you guys as we read this 2.47 gigabyte file, you won't even notice a change in the memory at all. So we'll be doing that. Now, so those are the files that we'll use, and as you can see, both of them, basically big data is just a bunch of these like stacked on top of each other, basically, but this is tick data for GBP USD 4x. So let's go back to our tutorial here, and let's go ahead and get started. So we don't actually need to import anything, but what we will do is we'll say the output file equals open, and we're going to open up a file. We're just going to call it example output.txt, and we want to open that with the intention to append it, since we're going to be doing this in chunks, right? So let me bump this up just in case we need the space. And now what do we want to do? Well, we're going to say with open, and what do we want to open now? Because that's our output file, but what do we actually want to read, right? We're going to read, we'll get to this one at the end, but first let's just read this file right here. So this is within my RAM, but I'll show you why it still matters and why you would want to use this even if you're using files within your memory. So we're going to say with open GBP USD underscore standard.csv, that's the name of that file. What do we want to do? Well, with open, you have 3 parameters that you can, in theory, put in. The first one you must have. The second one you don't have to have, but you would have, either append, read, write, whatever. But then there's a third parameter that we've never covered, and that would be buffering. That's the buffering parameter. Now, if you had, like you say, okay, we want to open it with read, then for buffering, you could just straight up put in a value. But for now, we'll just leave the second parameter empty, and we're just going to say buffering equals, and then here, let me just put it in, and we'll put 2 million bytes. The way this works is, if you put a number 1 there, it means it's going to buffer by line. So it's going to be line buffered if you put just 1. Any other positive number, you'll get a buffer of that size in bytes. So here we've got 2 million bytes that we're going to buffer by. But then you can also, if you put no parameter or a negative parameter in there, it's just going to use system defaults. So it's going to attempt to pretty much just open it up. Now, so we'll make that smaller. Now, the idea here is you would want to make this number as big as possible. So this will literally only buffer by 2 million bytes, right? So that basically translates right to 2,000 kilobytes or 2 megabytes. So very tiny usage of RAM, right? We could go by 20 megabytes if we really wanted. I'll just show you this tiny, tiny buffering amount. Now, the next thing that we want to do, and obviously the larger you make this buffer, the more efficient it's going to be generally. But for now, we'll just leave it pretty low, just so you guys can see there's pretty much no impact on RAM at all. So you would open that, and then we're going to say as f. So with opening this file, and we're going to just say as f, as f for file. What do we want to do? Well, we're going to say for line in f, we want to do something, right? So let's just say we do want to perform some sort of analysis on here. And our analysis, well, actually, here's what we'll do. We'll actually just modify the file. So this file right here, this GBP USD file, it is about 2.5 gigabytes. But we could probably knock some of that file size down by just removing GBP USD. We know it's GBP USD. It says it in the file name. So we already know what we're dealing with, so it's not totally necessary that we leave that little bit of text there. So we could already knock down some file size just by doing that. You could also perform analysis. You could, you could append a moving average to the end or something like that. But for now, let's remove GBP USD and see how much space that we save just by doing that. So let's come back here. And so we're going to say for line in F, what do we want to do? Well, we're going to say save line equals, and then we're going to say line.replace, and then we just want to replace GBP USD, and then also a comma, within the quotes. We want to do that and replace it with nothing. And the reason we want to do the comma is because it's comma separated here, and so we really want to get rid of, well, I can't really highlight it, but we want to get rid of all this. The reason also I'm not opening this up in Notepad is I literally can't. It's too big to be opened up in Notepad. Anyway, moving on. Now, coming back here, save line replace. Because obviously if you had it in Notepad, you could run this function in Notepad pretty much with a control H, find and replace function there. Anyway, but obviously like I was saying, you could do like a moving average or something else like that on this data or any other form of analysis really. Or you could save it to, I don't know, a database, which would make a whole lot of sense. Anyway, moving on. Out.write, or actually output.write. And what do we want to write to this output file, which is this example output.txt, which we're opening with the intention to append. What do we want to write? Well, we want to write that new line, so save line. And then basically once we're all done with this loop basically right here, we need to, sorry, just banged my mic. We need to do output.close, and we're going to close out of the output file. So that's pretty much it. Now we can go ahead and save it, and then we'll run it. And this will actually, our buffer size is pretty small. Maybe what I'll do is we'll run this one, and it probably going to take like a minute or so to get through all of this at 2 megabytes a line, or for each buffer. But anyway, the next thing I'll do is maybe we'll add a 0 to this and see how much quicker it goes. I don't really want to sit here and just lull the whole time, so maybe I'll pause it, but then you guys won't get a feel for how long it took. I guess I'll pause it. All right, it is all done. Let's go look at it. Here's our example output. So we knocked off 0.44 gigabytes, right? So 440 megabytes got knocked off of this thing. That's pretty good, I would say. So what I want to do, I wonder if I can do this. Yeah, okay, so it was created 2 minutes ago, modified 1 minute ago. So that tells you that sweet spot. Definitely pause on. The other thing, well, actually, here's what I'll do for you guys. This will make it. What's going on, everybody? Welcome back to another Sockets with Python tutorial video. In this video, what we're going to be talking about is basically just building on the last video where we reached the point where we realized things are still a little clunky when we have messages that are bigger than the buffer size that we selected, but also how do we maintain this stream of data? So, because we're finding that the only way that we can finally get our full message is to issue a close, which closes the socket and ends the client, so we'd have to rerun the client. Obviously, it doesn't work. So we did cover everything you need to send and receive data via sockets, so I'm sure lots of people are going to leave us behind and be like, I've got everything I need, but you probably don't, because it's going to get a lot more complicated than this, or you're going to be missing out on a ton of stuff that sockets have to offer you. with basically any time you want to send things bigger than your buffer size. So most of the socket tutorials that I've ever seen don't even talk about how you build the message. It's usually like a chat example. They use a buffer of like 2048 bytes, and they don't talk about what happens when you exceed that. So anyways, not going to do that to you guys. So how do we actually do it? How do you handle sockets that exceed your buffer, but you don't want to have to close this connection? You want to keep a stream open and all that. Generally, what you're going to do is use a header. Now, there's a million ways that we could do something with a header, and basically a header is going to notify your program how long is your message and maybe give some other information about your message. But in this case, we really just want to inform the program, hey, I'm about to send you a message that's 50 characters long, okay? And then once the program receives that first initial header, they're like, okay, I'm going to wait till I have 50 characters of data. Once I've got that, boom, now I know that message is done. Now I'm going to be waiting for a header again, and then the process repeats. So there's lots of ways that we could build a header. You can make a header have some sort of fixed pattern, like begin header, and then maybe end, end message, or who knows. You do something like that and it would work fine until people learned that that's what you use, and then they would start adding that to their messages just to have a good old time. So you don't want to do that. So what should you or what could you do? And one option is a fixed length header. So you just always have a header that precedes every new message, and it says how long is that message going to be, and then that way your program knows exactly how much to wait for, and then when it's all done, it relooks for that fixed length header. Nobody can really mess with that. Okay, so that's what we're gonna do. So now, how do we do a fixed length header? Well, enter string formatting in Python. Welcome to the Python basics. Okay, so first let's say you got a message, and that will be equal to our welcome to the server, right? Now what we want to do is get the length of that and issue that in a fixed length header. So you can't just say len message, because that might be, if it's under 100, it could be 2 characters, 1 character. If it's greater than 100, it'd be 3 characters. We need it to be a fixed length. So how do we do that? So the way we're going to do that is first we have to kind of decide, well, what is like the longest message we could ever receive? Okay, I'm going to go with 10. So 10 would be, that's 1, comma, so it's 4, 7, 10. So if you're thinking you're going to get a message longer than 1 billion characters, do something even bigger. Okay, but for now I'm going to go with 10. So what we're going to say is print, and then this will be f, so we're going to use an f string here, and then we're going to say len message, and then and this will be colon, less than, and then whatever the header length is. In this case, we're going to say it's 10. So now we'll print that out, and you see it says 22, but what you don't see is the extra characters, but if I highlight it, you can see it. It's a fixed length, it's 10 characters. The next thing we could do is we could actually append to it the original message. So we'll do that. And now you can see here, it precedes the message. Now if we said 20, it would proceed with 20 characters. So again, it can be as many as you need. So you can understand that eventually you can come up with a number, and it's not going to require a huge, your buffer will always be more than enough to handle your header size.
Hi everyone, in this video tutorial I'd like to take a look at buffer solutions. So the first question is, what is a buffer? And a buffer is essentially a solution that is able to resist a change in pH at a specific pH range. So what I mean is there are certain buffers that are really good at buffering and resisting change from, let's say, a pH of 2 to a pH of 3, and others may be better at, let's say, a pH of 7 to a pH of 8. So the next question then is, what's in a buffer? So let's take a look at that. Okay, so now let's talk about what you have to put into solution in order to make a buffer. So there are essentially 2 criteria that have to be met. The first thing is you have to have a weak acid or a weak base in solution. So the point here is it's weak.
Hi guys, my name is Ansari, and you're watching another tutorial on C programming, and in this tutorial I will be talking about buffers. So in my previous tutorial I talked about streams, and streams were simply pointers to a file structure, and that file structure contained all the information that was needed to extract information from a file or to store information into a file. So there is another concept, and that concept is called a buffer. So your keyboard is an external file, and your program resides inside your main memory. So when you press a key from your keyboard, when you try to enter a character from your keyboard into your program, that will take a lot of time because that character has to travel from an external file into your program. So this can be time consuming, and if your program needs that character rapidly, that might cause lags. Similarly, when your program is printing a character onto your display screen. So again, since the display screen is an external file, so it will take a lot of time for example, this character A to travel from your program into your external file so that your display screen can display that character A. So in order to solve this issue, buffers were introduced. And buffer is simply a small area inside your main memory, inside your RAM. And that area is responsible for storing information before that information is sent to your program, and storing the information before that information is sent into your external file or your external devices. So let me show you what I mean. First of all, there are different types of buffers. There's a line buffer, there's a full buffer, but in this tutorial, I'm going to be talking about line buffers. So suppose this is your keyboard right here, and you want to enter some information into your program. So you're going to type the information. For example, I type ABC129 and _5 exclamation mark, and then I press the enter key after typing all this information. So what will happen is that as long as I'm typing these characters from the keyboard, so these characters will be stored inside the buffer. And as soon as I press the enter key, these characters will be transported from the buffer into your program. And now keep in mind that the buffer is also inside the main memory. So the time it will take for those characters to transport from the buffer into your program will be very, very less compared to the time it will take for those characters to travel from your external file, which is your keyboard, into your program. So this is very convenient because the buffer, with the help of buffer, all these characters are instantly available to your program. So as soon as the buffer encounters a new line, it sends all these characters directly into your program. But in the previous case, if there was no buffer, then what would happen is that as soon as I press the enter, as soon as I press the character A, it would take a lot of time to reach the program. And then similarly, after A, I would press B, and then this would take a lot of time to reach the program. And then I would press C, and this would take a lot of time to reach the program. And then I would press 1, and this would take a lot of time to reach the program. So this will, this will cause lag. If your program needs all those characters instantly, it will cause problems because all these characters will travel slowly one by one into your program, and this will cause delays. So it is much better to store all these characters or values inside a buffer, and then when your program needs it, it can instantly.
Hi, this is Mike Callahan, Dr. FileFinder, and welcome to your Butterscotch.com tutorial on what is a buffer. Buffer has many definitions, but in computers, a buffer is just an area of memory where data is stored until the computer is ready to accept it. So we'll look at keyboard buffer. Now, whether you realize it or not, you have one, and you may well have seen it in action and just not realized it. So I'm going to do a graphical example here. I'm going to bring up the text editor, and let's just say that while you're in it, all of a sudden it freezes up. So you hit enter, and I'm intentionally tapping hard so you can hear it. You're hitting enter, and then you're tapping keys. I'm like, what's the matter with this thing? And then you hit enter a few more times. And then you hit a few more keys. And nothing's happening. And then all of a sudden, you get this blast of stuff on your screen. Well, what happens was that the stuff that you were entering was going into the keyboard buffer. And the buffer said, whoa, the computer's frozen. We can't go out there because it's locked up. So let's just stay here in the buffer until the computer's ready. So all those keystrokes, enter, 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 d, 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 all stayed in the keyboard buffer. And then when the program unfroze, they were all released from the buffer in one flow. So that's a classic example of a buffer. Your printer has a buffer. It's used for spooling. Spooling is really just saying that the data to be printed is sent to a buffer area, a spool, so that it can be printed from there rather than having to wait and freeing up the computer to do other things. In the early days of computers, when you had to print, you didn't do anything else. So if you had a term paper that was going to take 10 hours to print, you better not want to do anything else on your computer because it would spend 10 hours printing. Hence the creation of the print buffer. Every once in a while, you'll see an error that says either buffer overflow or buffer overrun, and that's simply a programming problem where the space that was allocated for buffering has been overrun, data has burst outside of the boundaries of the buffer, and it's caused a problem. So a buffer is just an area of memory that holds information until the computer is ready to handle it. And that's all there is to it. Hey, this is Doc. If you're looking for a cheap and easy way to put your own content on the web, go get domain names from hover.com. Just
In the previous lecture, we understand how to work with stream in Node. In this lecture, we will understand what is buffer. Buffers were introduced to help developers to deal with binary data in an ecosystem that traditionally only deals with strings rather than binaries. Buffers are deeply linked with streams. When the stream processor receives data faster than it can digest, it puts the data in a buffer. Stream in Node.js simply means a sequence of data being moved from one point to other point over time. The whole concept is you have a huge amount of data to process, but you don't need to wait for all the data to be available before you start processing it. A simple visualization of the buffer is when you are watching a YouTube video and the red line goes beyond your class here. And this is, I'm going to say buff. I'm going to call this buff variable. Now let me just save the changes and execute this file. When I execute this file, I'm going to have the result something like this. Bracket, I'm going to specify 0. So we have 3 numbers. These 3 numbers, each character at this position. So this statement will execute this file. You can notice here, if I try to print this buffer using toString, as I said earlier, buffer is right from here, and I'm going to call here a method, allocate write method buff.write. I'm going to write my buffer. So here I'm going to say, hey, like this. We allocated the size of this buffer 4. So we specify here 4 characters inside this write method. Now, just for that, let me save the changes and execute this file again. I'm going to have the same result. So using this technique, you can also
Hello everyone and welcome to Hazian Education World channel. Well, we have seen in one of the previous videos how to write to text files in Python using the open and write methods. But the process of writing to the disk is slow, and to speed it up a little bit, instead of calling the system on each write operation, a buffer is used, and the data is kept in the buffer as a chunk of information. Once this buffer is getting full, or once the file is closed, then the data is flushed automatically from the buffer. So if for any reason we don't or we can't wait for these 2 reasons to occur and we want the data to be flushed at time t during the program execution, we can do it by using the flush method. The syntax is pretty simple. It's file object dot flush, open and close parentheses. It has no parameter, and will not return any value. So let's see some examples. Okay, why I have chosen this name, but let's say 1000 to 1000. Right. See what will happen, what will be the result. It's empty. This is not written inside this, are still in the buffer. So the flush method. So the options. Okay, it's executed. Our file is not because we have. Is that enough to ensure that the data is written to the disk after using the flush method? Well, not really. In fact, there are two types of buffers. The internal buffers are the ones we have seen just now. They are used by the system buffer. And for this reason, there's another method called os.fsync method. And in order to use it, we will need to import the OS module. Find something similar to the following description. If you do from the first sentence, you can see
Hello and welcome to another video. In this one we're going to be talking about typing again in Python. And in particular we're going to be talking about the overload decorator and what that means and how you might go about using it. So let's jump into it. Okay, so for today we're going to be talking about some standard lib functions just because they're the easiest to kind of explain how this works. So I'm going to open up an interpreter. The first one we're going to be talking about is the indexing of a bytes object. Now a bytes object is a literal like this, and it represents a series of 1 byte integers on in a list or in a sequence. So for example, if you converted foo into a list, it's an iterable of integers. And the function that we're going to be trying to represent in typing today is actually the function that is this bracket operator of the bytes object. So when you pass in an integer into this bracket operator, you're going to get back an individual integer because it's a iterable of bytes. But if you pass in a slice, so this is the slice for 1 and onwards, you'll see you get back a bytes object. So we actually get 2 different types here, and that's going to be important later when we try and define a function for this. So let's write our function here, and I'm just going to call it bytes get item. It's going to be a little bit oversimplified here. But we're going to take in a bytes object, and we're going to take in the index of this. And the index here can actually be 2 different types. So from typing import union, it can be either a integer. Technically, it can be a indexable object, but we're gonna ignore that for the sake of this. So pretend it can only be an integer for this case here. You can also pass in other objects that can be, intifiable, kind of. Like you can't pass in a float, that doesn't work. But there are other things which have, I think, let's see, def index self return to foo. Yeah, so you can have a class which defines double index. We're not going to cover that on this case, but you can do that. And the other type that can go in here is a slice, and that's what this syntax is. This actually turns into slice 1 none none. You can see if we access it with that slice object, we'll get this back out. So this is kind of a little syntax sugar for this behind the scenes. But anyway, our bytes get item takes our bytes object, and it takes either an integer or a slice or an interval, but we're not going to cover that here. And naively, if I was just writing this without having access to overload, this would return, oh, that's off screen. Okay. This would return union of either integer for the case where we're just receiving a single item, or it's going to return another bytes object. And in our case, the definition of this is simple or is trivial because we're just wrapping this other function. But you might imagine this code looking like, if is instance idx int, return something, otherwise return something else. You could imagine it looking kind of like that. But we're cheating a little bit here, and we're just wrapping this function. Now, unfortunately, if you were to write the function like this and then use it, you would run into a bunch of usability issues because of this union. Because you don't, the type checker doesn't actually know which of these union types you would have. So if you were to have like, foo equals our bytes object, foo, and then we did, print bytes get item, foo. Actually, let's make it a number, and then I'll show you kind of a cool trick. Bytes get item 0 minus the ord of 0. So this will give us back, the number 1 out of this one sequence here. And you'll see if we run this, python 3 t.py, it succeeds and we get, the number 1 out. The problem is if we went to type check this, vm activate pip install mypy, and then run mypy on t.py, you'll see that mypy doesn't know how to deal with this on line 22. It doesn't know unsupported operand for type bytes and int. And the reason that it's saying bytes and int is because we have this union here. Now, of course, you can get around this by casting or other ways. I actually did another video on that, so I'll link that in the description as well. But we don't want to use casting here because we know that when we pass an integer in here, we should always get an integer out. And that's where overload comes into play. I'm typing import overload. And what overload allows you to do is it allows you to pick different type signatures and tell MyPy that this function actually has two different shapes. It doesn't actually do anything at runtime, but it is a way to indicate to the type checker. And the way you would do that is by using the overload decorator, overload, and you're going to define each of your different type signatures. So in one case, we have idx, which is an integer, and when it's an integer, we return an integer. And the body of your overload function can actually be anything. The most common case that I've seen is just to give it an ellipsis. I did a video on ellipsis also. I will link that in the description as well. And the other convention is to just butt all these functions together. You can separate them if you want to, but I don't know. I find that this reads reasonably well. Bytes. And our other flavor of this function here is when index is a slice, and that slice returns a bytes object. So these are the two, shapes of this type. And finally, you have the implementation underneath. Here, we can just leave this alone. This is the correct way to do this. And so now when we run MyPy on this, MyPy knows that this is an integer type and not a bytes type, so it can handle this properly. Another, couple functions that are standard library functions that have this are the divmod function, which takes in, t and t and returns t, tuple t. Now this t can be either integer or float, and that's what it supports here. And so you can see, you would have two overloads, one for integer and one for float, and that would allow you to have different types there. But there's a whole bunch of cases where you might want to do overloads like this. I actually found very few in my code, mostly because I tend to not like to deal with unions, so I would probably write maybe two different functions to handle something like this. But if you have one function that handles both, then overload is what you would want to do there. What else? Is there anything else I want to cover? No, I think that is it. But anyway, hello and welcome. I'm James Murphy, and welcome to the mind-bending world of Python metaclasses. Metaclasses let you break barriers and assumptions that you had about Python. Consider the example of function function overloads. If you've spent a little bit of time with Python, then you know that Python doesn't have function overloads. Here I try to define this function f 3 different times, but actually the second definition just overwrites the first and the third overwrites the second. So at the end here, there's just one copy of f, the last one. You could see this by trying to call the function with just one argument. If you do, you end up with an error. The typing module has a decorator named overload, but that doesn't actually solve the problem. So I would still get an error if I were to run this. But what if I told you that with a meta class, you can actually get true overloading? Just to show you how awesome meta classes are, that's exactly what I did. Now when I run the example, if I call f with an int, it calls the int overload. If I call f with a string, it calls the string overload. And if I call it with multiple arguments, it calls the 2-argument overload. I know what you're thinking. This is nothing short of mind-bending, face-melting wizardry, and you're not totally wrong. Before we can understand this example, let's go back and understand just what is a meta class in the first place. Oh, and by the way, I'm giving out some professional licenses to PyCharm. That's this editor that I always use in my videos. Be sure to stick around at the end to see how you can get a chance at winning a professional license for free. Every object in Python has a type. 42 is an int, hello is a string, the empty list is a list, and an instance of my class A is an A. Classes allow you to make instances of that class. But classes are also objects themselves. So what's the type of a class? In all of these examples, the type of the class is a type, which kind of makes sense. And just like 42 is an instance of an int is an instance of a type. At runtime, I can use int to create new integer objects. And just the same, at runtime, I can use type to create new type objects. By the way, if you're wondering about what's the difference between a type and a class, in Python 3, there's no difference. So if I say something is a type or something is a class, I mean exactly the same thing. As concepts of the language, type and class are identical. But literally in the language, they mean different things. Class is a keyword which you use for constructing types. It turns out that a class definition is actually just syntactic sugar for a specific way of calling the type constructor. Instead of using a normal class definition, I could equally well call the type constructor directly, doing something like this. I just need the name of the type, a tuple of bases that it's inheriting from, and then I run the class body, and then store those definitions from the class body in a dictionary called the namespace. Then I feed those things into the type constructor, and out pops a new class A. A slightly more accurate picture would look something like this, though. Again, I need the name and bases of the class. Then the namespace, or class dictionary, is created using this double under prepare method. The body of the class just gets treated as code, which gets executed directly in this new dictionary namespace. Metaclasses are a point of customization in this class creation process. A metaclass is just a class that inherits from the type class. That means, just like type, the job of a metaclass is to create classes. By defining our own metaclass, we'll be able to customize things like how the class namespace is created using prepare, or things that happen in the init or new methods of the metaclass. The default metaclass, if you don't specify, is type. So by changing the metaclass of a class, that means we're just going to substitute our metaclass in everywhere that you see type here. Here's the simplest possible example of metaclass. Here I just have a blank class. As we've already seen, if I create an instance of the class, the type of A is capital A, the class. But the type of the class is type. Now let's change the metaclass. A metaclass is just a class that inherits from type. You can change the metaclass of a class just by specifying it as a keyword argument in the class definition. So the type of capital A is now my metaclass instead of type. This gives another way to think about what a metaclass is. A metaclass is just the type of a type, or the class of a class. If you want to know at runtime what's the metaclass of a class, then just call type on the actual class. Calling type on an instance little a tells you what class created the little a. So little a was created by big A. Similarly, the big A itself was created by the metaclass, so type of big A is the metaclass. Here's a simple example. Load time meta automatically adds a new variable onto the class when it's created. It just computes how many seconds after some initial base time the class was created and then stores that as a class variable. Whatever we do in new, we do eventually need to make a super call and pass all of the arguments up to type so that it can actually create the class. And here we can see that we actually do have the class load time automatically added into the class. If I didn't have load time meta as the meta class, then this would just crash because that wouldn't be defined. Another extremely important property of metaclasses is that they are inherited. B inherits the metaclass of A, and therefore it automatically has its own class load time. Notice that the class load time is different than the one in A, so it's not just looking up the value that was in A. This is an important distinction between how metaclasses are used and how something like a class decorator would be used. You could use a class decorator to add something simple like this, just a class variable onto the class, but you wouldn't be able to make that property inheritable. If you're not doing something that's supposed to apply to a whole hierarchy of classes, then there's a good chance that it could just be done using class decorators. So what's an example where you would want to modify an entire class hierarchy? Well, how about a familiar example? Abstract base classes. Here's a stripped down version of how abstract base classes in Python actually work. Basically, you just inherit from ABC and then you mark some functions with abstract method. As long as there's at least one function that's still marked abstract, you're not allowed to create an instance of the class. So I wouldn't be allowed to create an A because F and G are abstract. But then I define class B that inherits from A and defines concrete implementations for F and G. So I would be able to create an instance of B. First, this abstract method decorator. Well, all it really does is set a secret attribute called isAbstract equal to true on the function and then return it back. Then in the meta class, we override dunderCall. Dundercall is called whenever you try to create an instance of the class. The default implementation of dunderCall is just going to call new to create the object and then initialize it using the init method. In ABC meta, we just change that. First, we get a list of all the methods that are still marked abstract, and then if there are any that are still marked abstract, then we just refuse to create an instance. Otherwise, we just use super to call the normal instantiation process. Another common thing that you'll see is creating basically a blank class that does nothing but inherit from the meta class. Doing this allows your users to inherit from that class to change the meta class without even knowing it. It's mostly just a convenience factor. The ABC example was kind of mundane. All it did is prevent instantiation of a class. It didn't really modify anything during class creation. And that's how a lot of metaclasses are. They do just pretty mundane things. Metaclasses alone are not this big scary thing that you have to be confused about. So how did metaclasses get their face-melting, gut-punching reputation? There's no limit to what you can do with metaclasses, so naturally they start to harbor all of your most mind-bending ideas. So let's get to it. How did I add function overloads into Python using a metaclass? The key to all of this is the prepare method. During the creation of a class like A, the body of the class is executed, and the local variables that are defined in the body are saved into a dictionary. If you define a prepare method, then its return value is used as that dictionary. In a normal dictionary, if I set f to be this function, and then set it again to be this function, and then set it again to be this function, at the end of it, it would just be this last function. The value of f would just be this last thing. But what if I created my own dictionary that when you set a value multiple times, it doesn't just overwrite the previous value, instead it creates a list of all the values that it's seen. That's the basic idea of this overload dictionary. So that's what I do. First thing, the overload decorator just sets the secret value, thunder overload, to true. Then in the overload dictionary, if it sees something with thunder overload equal to true, it's going to store those values in a list. I actually define my own overload list, which is just used to tell the difference between whether someone was just trying to store a normal list as a class variable versus if someone's trying to overload functions. The first time that I try to set a value for a given key in the overload dictionary, I either just put in the value as normal if it's not marked as overloaded, or I put it in a singleton overload list. If I try to set a value for a key that already exists in my overload dictionary, and that key is associated with an overload list, then I just append the value to the list. So every time I define an overload function f, it just gets appended onto this list. If I try to set a value in a key that's not associated with an overload list, then I just overwrite it like a normal dictionary does. Here's how you could use an overload dictionary. Here I define an overload function f, and then I just set some values in the dictionary. So I set the key a to be 2 different values, but in the final dictionary, it just has the last value because none of these values were marked as overload. Since f is marked as overload, when I add it to the dictionary twice, instead of overwriting the previous one, it creates a list and keeps track of both of them. So by changing a's meta class to overload meta and marking the functions as overload, now when I execute the class body, all 3 of those definitions of functions are going to be stored. So by using the overload dictionary, I can keep track of all the functions, but they're just stored in a list. So at runtime, how do I actually call one of the functions? That's what new accomplishes. The namespace that gets passed to new is going to be this overload dictionary that was created in the prepare method after the body of the class has executed. What I can do is just look through the namespace and replace any overload lists with overload descriptors. Descriptors are what famously allow you to, quote, own the dot in Python. A descriptor is any class that defines a dunder get, set, or delete method. If you set some value of a class equal to a descriptor, it changes how gets and sets on that value work. If I create an s and then execute s.someval equals 5, it'll actually call the descriptor's set method with the instance being s and the value being 5. Similarly, s.someval will call the get method. If you've ever wondered about how @property works, this is exactly what it's doing. So a descriptor will let me intercept attribute access on a class. So let's make an overload descriptor. When you try to look up an overload descriptor, it'll return to you a callable thing that knows how to pick one of the functions in the overload list. The overload descriptor takes in the list of possible function overloads. It also stores the signatures of all those functions using the inspect module. When you try to access the overload descriptor, I'm going to return some kind of object that's bound to the instance that knows about all of the overloads. I have to split things up into another class because attribute access, the time when you access this function, doesn't have to be the same time when you call the function. This acts exactly the same way that normal function lookup behaves. Here, if I have a class A with a function f, I can assign a variable func to a.f. But if little a is an instance of the class and I try to store func equals a.f, then func is going to be this bound method. This bound method just remembers the little a so that when you call it, it calls basically a.f with whatever arguments you pass in. When you construct a bound overload dispatcher, it just remembers the instance and a bunch of other things like which overloads and their signatures. When you go to actually call the dispatcher, it uses some algorithm best match in order to decide which of the functions in the overload list is the best match. Then it goes ahead and calls that function with its remembered instance and the same args and keyword args. I just did the simplest possible thing for finding the best match. Basically, loop over all the possible overloads, try to bind the arguments to the signature, and the first one that passes and matches the types, then I just call that the best match. So let's see it in action. A is a class with meta class overload meta. It has 3 overloads of the function f. One takes an int, one takes a string, and one takes 2 arguments. Looking at capital A.f, we see that it's an overload with 3 functions in it. But for little a.f, it returns a bound overload dispatcher. So this object remembers little a, and when you call it, it will call one of the 3 functions with little a and whatever other parameters. When I call little a.f of 1, it calls the int overload. A.f of hello calls the string overload. A.f of 1, 2 calls the 2 argument overload. And A.f of none doesn't match any of the signatures, so it raises a no matching overload exception. Well, as you can probably guess, using descriptors and checking signatures and type checking at runtime, it's a big slowdown. Let's compare an overload class versus just a function that checks its arguments and does 2 different things based off of that. In this case, using this overload framework is basically causing a 1.5 times slowdown, so that's not very good. If I change the implementation to something quick, like just returning 0, then it turns out to be 81 times slower. So yeah, doing all this signature inspecting and type checking at runtime is extremely expensive. Now, I know the overload thing was the coolest part of the video, but I can't let you go without letting you know about another application, code generation. This is not how data classes are actually implemented in Python. They're implemented using decorators, but here's just an example of another way you could do it. Let's define a data class meta type. When you construct a new class, it looks for any annotations on the class. Then it makes an init function. By that, I mean it makes a string, which is the string representation of the init function. So I make the literal code text from this make init function based off of the annotations, and then I just go ahead and execute that code. That allows me to do something like this, where I just define annotations on a function, and then it defines the init function for me. The possibilities with code generation and reflection are basically infinite, so I'm not going to get much more into that, but I just wanted to whet your appetite a little bit. Alrighty, that's all I've got. Stick around if you want to hear the rules for the giveaway. So I'm giving away 2 professional licenses for PyCharm and 2 professional licenses for CLion, their C and C++ editor. In order to have a chance to win, you must like the video, you must be a subscriber of mine, and you must make a comment with either hashtag Python, hashtag C, chances of winning.
Yeah, I'm not sure if I got everything there.
Hey guys, I'm back with a new video.
Hello and welcome to this episode of What Does This
Yeah, I'm not sure if I'm gonna study this stuff. I think it's better to just read the documentation, try to build something on my own, just so I can train and increase my understanding by trying to apply these things, the things on the library. I try to modify the script from Vivax to output something else. Might be interesting. I do need to study the debugger though. After I study this stuff, then I think I'm gonna search for cargo competition. I wanna download the data, and then I'm probably gonna separate a file for that, a folder, so I can open up and use the debugger to see the execution of all the functions. Ideally, it would be just the sklearn functions for creating the splitting the dataset, creating the network. I think I want to know how to build the layers. So I'll probably use the debugger for that to figure out what they are accessing, which files. I won't look at this.
Hello everyone, welcome back again. My name is Jess. In this video, we'll cover yet another important core module of Python standard library, which is pathlib. Now, pathlib is a module that helps us to work with paths in Python. So first, let us import the pathlib module by saying from pathlib import path. We'll not be going over the complete set of methods that it offers, but I will touch the most commonly used methods of the pathlib module. So let us set up a path first. So first, let us create a simple Python file and name it as hello.py. And here I will say Python is the best programming language. And now to set up a path, I can say path and use the path method, set that to hello.py. And now let us print the path that we get to the terminal. So print path and let us run the file. And you can see we are getting hello.py. So our path is pointing to this file, which is hello.py. Now let us try to get the home directory of the current user. So for that I can say print path.home and let us run the file. And you can see we are getting /home/runner. And this is the home directory in which we are currently working in, which is the REPL.it's home directory. Here we are using a REPL to write our code. In your case, output will definitely be different. Getting the home directory of the current user. And we can also check for the existence of the path. So I can say path.exists and let us run the file. And of course, we expect it true as the output because we do have a path. Now let us check whether the path is a file or is a directory. So to check whether the path represents a path to a file or a path to a directory, checking whether the path represents the path to a file. So for that I can say path.isFile and invoke that, run the file, and you can see we are getting true as the output. So that means the path, which is hello.py, points to a file. Now in order to check whether the path represents a path to the directory, I can say path.isdir and let us run the file. So you can see we are getting false because stem and invoke it.
Package do. I'm your host Navil, and today we're going to be taking a look at the pathlib package. So without much further ado, let's head in there. The pathlib package is created to make working with file paths easier. To begin with, what we're going to do is create a path that points to our current working directory. There are two ways to do this. One way is to just give the first argument of the path object constructor as a dot, and the other option is to do path.cwd. The coolest thing about pathlib is the / operator that allows you to concatenate paths. So to show you that this thing actually works, what we're going to do is hit the resolve method, which is going to give us the full path, meaning that you're going to get the fully expanded path name. And what that also means is on operating systems like Windows, what's going to happen is it's going to turn the / into backslashes. The pathlib library is really interesting in that it works with both Windows and Unix-based systems. So if you just create a path object, depending on your operating system, Python will automatically choose the right subclass for you. In this case, we have the POSIX path. But if we were to do this on Windows, we would have the Windows path. Before we can really dive in any further, we need to talk a little bit about the different path classes. In general, always instantiate a path using the path class. However, if you want to do something on a Windows file system being on a Unix file system or vice versa, you might want to use a pure Windows path or a pure POSIX path. All path classes inherit from their pure path counterparts. Pure paths are kind of like abstract classes in that they're abstract paths. So whenever you actually create a path, you probably want a concrete path, so instantiating it via the path class will give you a POSIX path or a Windows path. However, if you want to work on Windows from Unix or from Unix on Windows, you probably want a pure Windows path or a pure POSIX path. Now heading back to the methods that exist on top of the path class, we can try out the exist method that tells us whether a file path exists on disk. In this case, it does not, so we can just use the mkdir method to create that directory in question. One really interesting thing that I found out about the pathlib package while using it is that there are a lot of Unix commands that are baked into the path object, like mkdir and touch. Now I know that the path was created, but I can double check by injecting a file reference in the string here and seeing if autocomplete completes the file path. Looks like it does, and it also shows us that there are no files in that directory, so we're good for now. Now, the path object provides a very rich API for dealing with file paths. We've already taken a look at mkdir, exists, and other methods, but it also has properties like the parts property that gives you all the different parts in a file path. But if we run this, we're going to get an error simply because we already have a directory created. Now, there is one thing that I need to highlight here, which is that even when a directory exists, you're going to get a file exists error. I know that's weird, but that's one of the caveats. With that tangent aside, most methods that describe your file paths like absolute or resolve will return a file path as well. And if we comment out line 8, we'll be able to see that printed out. Heading back to / operator awesomeness, you can do /equals and then a file path, which is in a string, and that will append that to your file path as well. So it's a very natural way of appending new directories or new files to an already existing path. Now, of course, this path does not exist. So let's go ahead and create it with the touch method, which I've mentioned before already exists on our path object. And once we run that again, we can see that the path indeed does exist. Now, moving on to comparing file paths, one thing that I've noticed is that when you create a path for the first time, it is going to be created as a relative path. And if you invoke the absolute method, it's going to give you the absolute path. However, if you compare two paths which actually point to the same thing, but one is absolute and the other is relative, Python is going to tell you that they're two different paths. To remedy this, we have something called samefile, which if you compare two paths that are relative and absolute, but they're actually the same path, Python will let you know that they're the same path. Now, a lot of you might not really like using the slash operator, and in that case, you can just go ahead and use join path, which is available on any path object to join your paths. However, don't join your paths with a slash in the beginning. If you want to add a longer path that has a directory or two in it, make sure you do that by adding more arguments to the join path method instead of putting forward slashes in the middle of that file path. Now, let's get rid of this horrendously long method call and focus on the next big thing, which is iterating over the files in a directory. So what we're going to do is iterate over the parent directory of our current file and print out the only thing there. But we can do so much more with a file object. The match method on any path object allows you to match it against any glob style pattern. In this case, we can check to see if there are txt files using star.txt.
Right back.
txt as our glob pattern. Well, executing that seems to work, so let's try with Python files. And it looks like there are no Python files there, but there might be Python files of the parent directory of our new file path. And yes, indeed, there are. Throughout this episode, we've been extremely kind to files. So now it's time to delete them. When I first started out with pathlib, I tried to look for the delete method because that seemed the most logical thing to call deleting a file. However, the method that you want to use is something called unlink. And what unlink does is basically get rid of files, but also symlinks. However, you can't use unlink for directories, so it's best to use rmdir to do that job. Now, you might have a lot of code that uses the os.path module or shootail, and working with those libraries before used to be a problem because you needed to turn your path-like objects into strings. But after Python 3.6, you no longer have to do this with pretty much any part of the standard library. But in the case that you do, you can always turn your path objects into strings easily. All path objects also come with a .open method that you can use to open a file, and you can use that with a context manager as well. So it really comes in fully featured. But otherwise, that's all there is. There are some other things that you can learn from in the documentation, but all in all, pathlib is a small but very functional library with a very rich API. Well, folks, thank you so much for watching, and we hope you subscribe to our channel for more awesome Python and PyCharm content.
Welcome back, everybody. So today, what we're going to be doing is we're going to be talking about a specific Python library. That specific Python library is called pathlib. So what's the whole purpose of this video? Why are we even talking?
Yeah, I don't think I'm gonna watch this anymore. Just gonna search for this one. Because I kind of already get it, how it works. I want to study the other stuff first.
So previously, we've been focusing on absolute file paths. The entire idea, again, is that
I guess this command is just find the relative path. So I'm gonna... Okay, so I'm done with the contents of this file. These ones are just the description of some functions of the inspect module. I'm gonna watch this video, then read these libraries again. So I might search for code execution and frame.
Welcome to my first ever live stream where I'm going to be showing you how to get started using the Python debugger tool. The Python debugger tool, or PDB, is a tool that will save you an incredible amount of time. It's really useful, and when I used to debug my Python applications when I first got started, I used to just, if there was a problem and I wanted to know what kind of variable was set to what value, I would just simply print that out on the screen by literally putting print commands in my code. And I would get to the point where I'd have to put print with tons of equal signs or something like that so I could actually see the output amongst all of the logs of the code that I was running, so I could actually identify where my output was, so I could inspect which variable was set to which value. This all changed when I discovered the Python debugger tool. It saves me so much time, and I use it all day, pretty much every day when I'm debugging my code. Anytime I have any issue with my code or I want to see what's going on, I use the Python debugger tool, and it helps me figure out how to fix the bug. So I'm going to be showing you how to use the Python debugger tool with a very simple Python project that I've created and shared on GitHub. So if you look at the notes of this video, you can see a link to the demo JSON printer project. Now, this is a very simple project that I created that is just, it only contains 2 files. I'll show you on the GitHub page first. So if you want to find it, it's under London App Dev Demo JSON Printer. And it just contains these 2 files, the hello debugger.py file and the sample.json file. All it is a very basic script in Python that we run using the command line. And what it should do is it should output the values of the sample.json file. It should output the keys and the values next to each other. But there's a couple of bugs that I've deliberately put into this code, and it currently doesn't work. So when you claim the project, if you type Python hello debugger, you can see that it gives this attribute error, non-type object has no attribute items. Now, it's a pretty basic issue, pretty simple bug, so you'll probably be able to figure it out pretty easily just by looking at the code. But I just wanted to create a simple script that I could use to demonstrate the Python debugger tool and show you how to use it. So what you do with the Python debugger tool is you basically set a line in the code which will stop the execution and allow you to manually step forward or inspect the different values in your code. It's a bit similar to breakpoints. If you've ever developed a Java application or like an Android application or something, you can set breakpoints in the code so that when the execution gets to that specific breakpoint or the line that you've set the breakpoint on, it will stop the execution and give you an interactive. When you leave the Python debugger line in my code, and if you have a good run our script, the 3 main things that should give us the attribute error that we saw earlier. Command that's really useful. It will step in print, and we can see that this CONT.
That's gonna be useful.
Everyone, myself Sonali, and in this program I'm going to explain how loader works. That's implementation of loader in Python. So the output of the assembler will be input for the loader. So let's see what is the output of the assembler. So this is the output of the assembler. And let's see. So what I have done, I have to take a list of tokens where it is 4x in range of 4. Then I'm opening the file object .txt, .txt where text will be equal to 4 read lines, where every code will be read line by line and it will be stored in the text. You can see this notation. So this splittance can be will be done. The object code will be plus token 0. And in that line they're asking like plus token. This h will be considered as 0. That means copy. So program name, that is copy. Then for lines in token, 1 column. This column means like 1 column. 1 column. That means after column there is nothing. That means it will go to e. That is end of the file. And counter is equal to int for ELEMS in line 3. Then again that column that I have explained.
Hello everybody, and today we are going to see the sys library. The sys library is related to that system, and it has a lot of attributes and functions related to that system. So first, sys is a built-in library. You don't need to download it from external resources. And to import it, you just need to type import and sys. Let's see our first attributes. For the first one, we have platform. So to use this, you just need to type sys.platform. What is platform? Platform is a string containing a platform identifier. So, for example, if you are
Just gonna change the name of the file. Can delete the other file. This one. I'm gonna put this before this one.
Using Windows as a system, the platform will give you a string containing Win32. If you're using Linux, it will return Linux, a string Linux. To print it, just print this, and you'll get Linux and Win32 as output. For the second attribute, we have here copyright. So to use it, just type sys.copyright, and here, because it's an attribute, don't put two parentheses, be careful with that. And copyright is a string containing the copyright of the Python interpreter. For the third one, we have version. We can use it the same way as our previous attributes, and it is a string containing the version number of the Python interpreter and additional information on the build number and compiler we are using. Let's try those three. Okay, let's first import the sys library, then let's print sys.left4, and let's see what we get. Okay, as you can see, Win32, and that's because I'm using Windows. For this, our second attribute, we have copyright. You can see all the copyrights here to this interpreter, which is Bashar, by the way. And here's the third one, is Wiz, which is version. It will give us the Python version. I am using this interpreter and some other compiler information you can see here. And now we have two functions we will see. The first one is stdout.write, and this stdout refers to standard out, and it takes a string as a parameter. So what that do is giving an output as a statement. So it works exactly like the print function. For our second function, we have here stderr. The difference between this and this one is that the message output here is in red. And to make it clear, let's put a line between both. We have also an output with a red color, but you can see now that it is an error message, so it might be executed .get size off, and as a parameter it takes variable, any variable type. For variables, the first one is integer, the second is, we'll start with A, 14 bytes, second which have argv, sys.argv, that's how we call it, and it's a list of command line arguments passed to a Python script. So when you want to execute a Python script in the command line, you can store all the argument, pass it to that script when executed. You can store all of those in a list, which is argv. We will see that and make it more clear by doing the code. Okay, and now let's see first how it does look when we want to print the system.rv. First, let's go to the terminal, or you can go to the CMD as you like, and write. This is the script name. Okay, because we are in the path, we don't need to pass here our path, and press enter. Here is our result, which is a list, as we saw, and it contains just one element, which is our script itself, because our script is the first argument passed when we are executing this file in the command line. So, for example, if we want to launch this with some more, the name, the age, and if the user was a female or a male, then we want to print hello and put this name, and you are, for example, 19 years old, you are a male or you are a female. Let's try this program now. Let's now print the name. Then we want the age index, which you can index.
Hey guys, if you have been coding in Python for a while now, then you must have seen the term sys.rv in some Python programs. So sys.rv is actually a parameter which is defined in the sys module, obviously, right? So sys.rv is a parameter which does some special things which we are going to explore in this particular video. So without any delay, let's get started. Okay, so let me start by showing you a very simple Python program. So it's a very simple Python program in which I ask the user to enter some number n, and then I run a loop n times in which I fill up my empty list nums with the integers which are provided by the user, and finally I return the sum of those integers to the back to the user. So that's all this program is doing right now, and let us try to run this program a bit. Okay, so this file test.py is actually on the desktop right now, right? So if I just do python 3 test.py, it's asking me to enter n, so let's put it 3. So now I have to enter some 3 integers. Let me just do it.
Thank you everyone for attending this talk. I'm Nikhil, and I'm going to talk about how Python does call stack evaluation and how it implements stack frames.
This program is working.
So I've used Python for small tasks for over a decade, but it's only been about a year since it became my primary language.
It is prompting the user to enter the numbers at several stages of running the program, which is quite frustrating for the user sometimes, because a better way is to just give all the arguments in this complete command. In this particular case, this command contains only one argument, which is test.py. Okay, so right now this is what command and arguments look like. And what you have to do is that you have to import the sys module and program while you try to run it. So let me just try to print it for you. Okay, so I will now try to print it. So let's do this. Okay, so look at that. I get go back to our main goal, which was to create a program which can return me 1 to 1, and now as you know that all the arguments into integers, and then I do not need to write any input statement at all because the user is already giving me all the data that I need. So that's it. So now let me just run this python 3 test.py, and look at that, I get output as 6. Let me make it 4, I get 10, right? So it's working absolutely fine. So this is how you can get the list of inputted command line arguments by using the sys.rv parameter.
So at Dropbox, I work on the desktop client, and most of it is written in Python. Thank you everyone for attending this talk. I'm Nikhil, and I'm going to talk about how Python does call stack evaluation and how it implements stack frames. So I've used Python for small tasks for over a decade, but
for some reason this is lagging a lot. This video.
It's only been about a year since it became my primary language at Dropbox. So at Dropbox, I work on the desktop client, and most of it is written in Python, even though it functions as a native app. So the way we achieve that is that a lot of our libraries eventually use native code to talk to operating systems, and native code can do bad things, like it can cause seg faults, it can do weird thread race conditions, and so on, and all of these lead to programs crashing. So this is obviously not a great experience for our users. So we do need some way to be able to know when users are crashing and why they're crashing. So the way we have done this for several years at Dropbox is to have a signal handler. And a signal handler allows us to trap certain kinds of conditions within the process and then run some code to capture what went wrong and upload it to our servers. The problem is there are some limitations to the signal handler. For one thing, it has to be in Python because all our networking stack and stuff is in Python. So if the crash happens before Python even started or before the signal handler was installed, then we don't get any crash reports. Similarly, I don't know how familiar people here are with Unix internals, but signal handlers interrupt the program indiscriminately, which means if you try to do anything fancy within them, you can end up in deadlocks or all sorts of bad stuff. So in late 2016, we started to migrate to this thing called CrashPad. So CrashPad is a piece of captures a crash. It ends up in this suspended state. And then Crash. So this is where my journey started, but it definitely makes reasoning. So there are these 3 functions that appear in the C stack for every Python function here. So we can deduce that py_eval framex is something important. For the rest of this talk, I'm assuming Python 3.5. Some of these details change in Python versions, so just be aware of that. So py_eval framex is the workhorse of the Python evaluation loop. It is actually written in C and is about 3,000 lines long. So this is the simplified version in Python. So the way Python works is that your source code is translated into something called bytecode. If you want to know more about that, James Bennett gave a talk at PyCon this year about that. So basically, each of your Python source lines is translated into some simple instruction like binary addition or call function. And call function here is the important one. Like every time you actually call a function, that's what this gets translated into. And then when it encounters a call function, it actually like calls the C function call function that eventually degenerates into fast function. And that is how we get the stack that we saw before, where there were like these three things that kept interleaving with each other. And now you've been noticing that there's these frames and this by thread state and so on in this. These are all the data structures that these three functions manipulate to evaluate Python code. So let's dig into that next. So lots of C structures coming up. This is literally code from the Python interpreter copied here, and I've removed some things to make it easier. So every Python interpreter has one PyInterpreter state structure. This stores a lot of information about the overall state of the program. And then for every thread, every Python thread, there is an associated Python thread state structure. In CPython, Python threads and native threads map 1:1. So essentially, every native thread has one Python thread state. So let's look at the interesting bits in this structure. For one thing, we have the thread ID. This is dependent on the operating system and uniquely identifies the thread. We see that there's a pointer to the interpreter state. This is like a back reference to all of them pointing to the same interpreter state. And then there's the struct frame, which we're going to see in just a bit. And finally, you'll see these two pointers, struct previous and next, both of which are of type thread state. So anybody who's done C programming might immediately recognize this as something called intrusive linked list. And what this means is that this is just a data structure that has a linked list within itself, pointing to the previous and next thread structures. So you can see that when the main thread starts, it has a reference to the interpreter state. And then when you create a new thread, thread 1, it's going to use these previous next pointers to create a link between main thread and itself. And similarly for thread 2, and the interpreter state's thread state head maintains the head of this linked list. So you can just iterate through them to see all the thread states. And then finally, we have the frame. So each thread state is responsible for evaluating one Python thread, right? And so each function call is represented by what's called a frame. The nomenclature comes from native code execution. And as you make nested function calls, we keep building up these linked lists of frames. And so this f_back can be thought of as a linked list pointer to the next element code to access this frame. And it evaluates a really simple function. Local variables are going to get operated upon. It refers to the instruct bytecode. Since it's the first function call, f_back points to the module, and then the thread states and load pointers to Py objects. Here, local variable that we're going to assign. And then there's a stack string to the index 2 because that's the. From here, we load a constant 5. The entire Python evaluation loop can only 12, and then we hit the things happening. So dig into these frames if you need to. And based on everything that we just saw, we can replicate a lot of this functionality ourselves. So for example, here it is. We can access the top frame in each thread using the sys.currentFrames function. And then we can access various attributes to print a stack like that. So that's what we need to do to get it working in our crash reporting, except we have to do all of this in C code outside the interpreter. So there's only one more thing remaining. We know how to walk the stack. We know what data structures are involved to find the stack for each thread. So what's the starting point? The interpreter, the thread states, and the frames are all being dynamically allocated. So we don't have a good way to find the beginning of them. Fortunately, it's all just code. One thing I've realized in my career is that it's all software, and anytime like something isn't providing you enough information, you can just make a change, and it'll work. Only remember that when you change the interpreter, you're taking dependencies on stuff that is guaranteed to break at some point. So the one thing we did was we used thread local storage. So Python uses thread local storage to store the thread states. What I mean is that thread local storage is an operating system provided structure where you can have multiple threads sharing the same key, in this case 5, that points to different values in each thread. And so you can see that each thread state is preserved separately. And this is already done by the interpreter. All we needed is a good way to access auto-TLS key. So we use something called a section, which is all modern OSs, their executables allow you to like name regions of memory with a well-known name. And that way you can just like later, oh, give me the section that's named this, and it'll give you the range of memory you need to look at. And with that, we can go and walk our entire data structure. So eventually we'll reach the frames. And we already saw how to get there. Once we get there, we can use the file name and the name from the code object. These are just Python strings. Decoding Python strings can be a talk in itself, but we just assume they're ASCII and read out the bytes. The other thing we need to do is the code object has a first line number. And the code object also, instead of like wasting space mapping every bytecode to an absolute line number, has a lookup table called lnotab that stores like a compressed form mapping. And so we can decode that and then use f_last_i to look into the table, and then just add the first line number to it to get the absolute line number in our source code. And there's a documentation in the Python interpreter on how that works. So that's it. That's like a lot of details. When we put all of them together, you can go from that to that. And once you get this for every user who's ever hitting a crash, solving bugs becomes like that for Python engineers, right? So this kind of low-level tinkering is not only fun, it makes our engineers significantly more productive. If you haven't read the blog post, Dropbox moved from Python 2 to Python 3 over like several million lines of code, shipping to hundreds of millions of clients. We wrote the blog post 2 weeks ago, so I recommend you read that. The crashpad effort was very instrumental to that, because without accurate crash reporting, we wouldn't know if we broke any users while doing this migration. So to recap, the Python interpreter stores a list of threads and so on, and there's frames on each of those threads. And a frame is the basic unit of evaluation. And we learned that we can leverage these internals to ship more quality software. There's some related works around profiling, but I'm out of time, so I'm not going to go into that. But basically, you can use the same techniques to get a sense of how fast your code is running using two profilers called PyFlame and PySpy. They use exactly what we did today to just do it faster. So I would like to thank my colleagues Jonathan Chin and Max Belanger, who are not here, for
is a dynamic data structure maintained inside the computer's RAM by the operating system. Its purpose is to control the way procedures and functions call each other, and to control the way they pass parameters to each other. A call stack is maintained for each task, and indeed for each thread. It's sometimes referred to as the machine stack, or the execution stack. More often than not, it's simply known as the stack. Consider a scenario where procedure 1 calls procedure 2, which in turn calls procedure 3, which in turn calls procedure 4. Let's suppose also that procedure 2 has 2 input parameters, and so does procedure 3, and so does procedure 4. Also, procedure 2 declares 2 local variables, as does procedure 3 and procedure 4. So what happens when procedure 1 calls procedure 2? First of all, any parameters which procedure 2 is expecting are pushed onto the stack. They're pushed onto the stack in the reverse order to which they were declared in procedure 2's parameter list. Next, the return address of procedure 1 is pushed onto the stack. This comes from the CPU's program counter, and it will be used later to return control back to procedure 1 when procedure 2 is finished. It's sometimes called the instruction pointer. Now that procedure 2 is in control, any local variables declared inside procedure 2 can be pushed onto the stack as well. So at this stage, procedure 2 is up and running, and it has what's called a stack frame. Procedure 2 can traverse this stack frame to get a hold of any data it needs. Suppose now that procedure 2 calls procedure 3. As before, any parameters which procedure 3 is expecting are pushed onto the stack. Next, the return address of procedure 2 is pushed onto the stack. This comes from the CPU's program counter. Finally, any local variables declared inside procedure 3 are also pushed onto the stack. So procedure 3 is now in control, and its stack frame is in place, so it can get a hold of any data it needs. When procedure 3 calls procedure 4, we see the same steps again. Any parameters which procedure 4 is expecting are pushed onto the stack one by one. The return address of procedure 3 is then pushed onto the stack, followed by any local variables which have been declared inside procedure 4. Procedure 4 is now in control. When procedure 4 has finished, the stack will be torn down. So, procedure 4 is now returning control to procedure 3. First of all, any of procedure 4's local variables are popped off the stack. Procedure 4 can then pop off the return address to repopulate the program counter and return control back to procedure 3. In this particular scheme, procedure 3 is responsible for cleaning up the rest of procedure 4's stack frame. So procedure 3 is now back in control, and it can pick up from where it left off. When procedure 3 returns control, procedure 1's return address is obtained, the program counter is repopulated, hence it's the responsibility of the calling procedure to clean up the stack once it's regained control. In some literature, you will see that the return address is pushed onto the stack first, before the parameters. The way this actually works depends very much on the machine architecture, and of course the machine language. It's also worth saying a little bit about how functions return their values. Again, depending on the architecture, function return values may be passed back specifically, and of course the machine language. Address is crucial to return control back.
This channel has a lot of good videos. That seem to be good. Operating system, computer hardware, architecture, JavaScript, bubble sort, insertion sort. The one that catches my eye is this one, and computer hardware and architecture. So I'm probably gonna watch this.
This diagram illustrates the essence of a segmented memory management system. On the left are some of the programs that have been installed.
First, I'm gonna read this stuff. I'm gonna read this again, and the other one, the article, and then read this library here. So these ones I remember. These ones are the important ones, I guess. Next inner traceback object called by this level. Next inner traceback object called by this level. Next, outer frame object, this frame's color. Built-ins, namespacing by this frame. Code objects being executed in this frame. So this has everything I need, pretty much. Global namespacing by this frame. Index of last attempted instruction in bytecode. Current line number in Python source code. Local namespacing by this frame. Tracing function for this frame or none. Number of arguments. String of raw compiled bytecode. Tuple of names of cell variables. Tuple of constants used in bytecodes. Name of files in which this code object was created. Number of first line bitmap. So when I'm trying to modify the VX script, I'm going to use these functions here. Stack size, virtual machine stack space required. Name with which this code object was defined. Number of local variables. So what I want to know is how library functions and classes are connected to each other. That's the best way to describe it. And then for the execution flow, I'm gonna learn the debugger stuff. So the graphical representation is about how libraries are connected. How the files of libraries are connected to each other. Which the graphs that I already have give me a good overall picture of what's happening. Then yeah, but I want to see if I can modify it so I have more information, and also to practice using this stuff. Well, there's traceback here as well. Name of module in which this function was defined. Frame object at this level. Index of last attempted instruction in bytecode. Current line number in Python source code. Yeah, this is super nice. Oh, I need to put this on the favorites as well. So now let me look at the sys library functions. Call tracing, call func args while tracing is enabled. Tracing state is saved and stored afterward. This is intended to be called from a debugger from a checkpoint to recursively debug some other code. Built-in module names, a tuple of strings containing current frames, return a dictionary mapping each thread's identifier to the topmost stack frame currently active in that thread at the time the function is called. Note that functions in the traceback module can build the call stack even in such a frame. This is most useful for debugging deadlock. This function does not require the deadlock threads cooperation, and such threads call stacks are frozen for as long as they remain deadlocked. The frame returned for a deadlocked thread may bear no relationship to that thread's current activity by the time calling code examines the frame. This function should be used for internal and specialized purposes only. Raise an audit event, sys current frames with no arguments. breakpoint hook. This hook function is called by built-in breakpoint. By default, it drops you into the BDB debugger, but it can be set to any other function so that you can choose which debugger gets used. So trace breakpoint. I think we'll now read this article first. Tracebacks are report containing the function calls made in your code at a specific point. Traceback are known by many names, including stack trace, traceback, backtrace, and maybe others. Python the term is used as traceback. When your program results in an exception, Python will print the current traceback to help you know what went wrong. Here's an example to illustrate this situation. Okay. Traceback, output name error. How to read the Python traceback. The Python traceback contains a lot of helpful information when you're trying to determine the reason for an exception being raised in your code. In this section, you walk through different tracebacks in order to understand the different bits of information contained in the traceback. So, diagram below. So this is just explaining when stuff goes wrong, which is not what I want to know. You guessed learning, this makes sense. Enter some specific output. The code below is used to illustrate traceback. How do you log a traceback? Getting an exception is the resulting Python traceback means you need to decide what to do about it. Usually fixing your code is the first step, but sometimes the problem is with unexpected or incorrect input. While it's good to provide for those situations in your code, sometimes it also makes sense to silence or hide this exception by logging traceback and doing something else. Some more real-world example that needs to silence Python tracebacks. This is the request library, you can find out more. This code works well, blah blah blah. Sometimes the real connection error. The Python traceback here can be very long with many other exceptions being raised and finally resulting connection error. If wrap of any line, I try long. But this is not saying log the traceback in the script by importing the logging package. Oh, so that's why this logging is used ever. Getting a logger and calling .exception. On the logger in the accept portion of the try and accept block. The request logger.exception. Your final script should look something like the following code. Python traceback contains great information. Python's built-in traceback module can be used to work with and inspect tracebacks. The traceback module can be helpful when you need to get more out of the traceback output. It will also be helpful debugging your code.
On the computer's hard drive. These are just files.
So that's how it works. This function returns a tuple of 3 values that give information. Prefixes, accept flags, float info. Return a frame object from the call stack. If optional integer def is given, return a frame object. Get trace function is set by set trace. A list of metapath finders, objects that have their find spec methods called to see if one of the objects can find the module to be imported. This is a dictionary that maps modules names to modules which have already been loaded. This can be manipulated by to force loading of modules in other strings. A dictionary acting as a cache for finder objects. The keys are paths that have been passed through syspath hooks, and the values are the finders that are found. If a path is a valid file system path, no finder is found, then none is restored. The string contains a platform identifier that can be used to append platform-specific components to syspath sys. Set trace. Set the system's trace function, which allows you to implement a Python source code debugger in Python. The function is thread specific. For a debugger to support multiple threads, it must register a trace function using set trace for each thread being debugged, or use threading.setTrace. Trace functions should have 3 arguments: frame, event, and arg. So it was the function that Vivex used here. Sys set trace. So maybe threading set face should be the one used. Stack size, return the stack. Frame, event, and arg frame is the current stack frame. Event is a string call. Is a string call line return exception or OP code. Arg depends on the event type. The trace function is invoked with event set to call. Whenever a new local scope is entered, the trace function is invoked with event set to call whenever a new local scope is entered. It should return a reference to a local trace function to be used for the new scope, or none if the scope shouldn't be traced. Local trace function should return a reference to itself. If there is an error occurred in the trace function, it will be unset. A function is called or some other code block entered. The global trace function is called, arg is none. The return value specifies the local trace function. Line the trace, the interpreter is about to execute a new line of code or re-execute the condition of a loop. Local trace function return. How to build a graph. The trace back. Right. I'm trying to make a pie chart in Python and I keep getting this trace back. How can I create a direct graph using Python? I think already this is the article I was reading. Yeah. Yeah, so apparently it doesn't exist, or at least I'm not getting. Maybe if I search for something else. It would be good if I had the full graph of all the libraries and how they interact, and then I had on top of that a color that showed the execution path. So if I had a graph like that one, so a graph like this for the overall matplotlib, and then a red arrow for a specific program that shows what thing got executed first, like show the flow of the execution. And problem is I would need the file location as well.
The logging module in Python gives you everything you need to report progress and problems in your code. It would be nice if developers and machines were 100% reliable. But let's be honest, life is messy. You're expecting an integer, someone hands you a float. You call a cloud API, the service is down for maintenance. A wide range of problems can happen that are out of your control. With logging, you can leave a trail of breadcrumbs, so when something goes wrong, you can determine the cause. Hope for the best, but plan for the worst with logging. Logging allows you to write status messages to a file or other output streams. These messages contain information on which parts of your code have executed and what problems may have arisen. Each log message has a level. The 5 built-in levels are debug, info, warning, error, and critical. If you want, you can create additional levels, but these should suffice for most cases. Let's now write a program and use Python's logging module to help us track down bugs and leave a record of how our code was used. First, import the logging module. Now look inside. This module is packed with features. It can be a bit overwhelming. The entries in all caps are constants. The capitalized items are classes. And the items that start with a lowercase letter are methods. Today we will keep things simple by setting up the logging system using the basic config method. Next, we will create a logger using the getLogger method. We will then use the logger and adjust its features until it works the way we want. Let's now switch to input-output mode. Import the logging module. Let's first configure the logging system and create a logger. Call the basic config method and pass in a file name. Python will write all the log messages to this file. If the file does not exist, Python will create it. Next, call the getLogger method to create a logger object. You can give your logger a name if you wish, but there are some subtle issues with logging names, so today we will keep things simple and work with one logger without a name. This is known as the root logger. Let's now test it. To write an info message, call the info method and pass in a string. Run. You can see that the lumberjack.log file was created. Let's look inside. This is disappointing. Our log message is nowhere to be found. Why is this? The reason lies in how we configured the logger. Let's print the level of our logger and run again. 30. What does this mean? In the logging module, the 6 built-in level constants are not set, debug, info, warning, error, and critical. These constants are integers with values of 0, 10, 20, 30, 40, and 50, respectively. Loggers will only write messages with a level greater than or equal to the set level. Our test log message was an info message, which has a value of 20, but basic config sets the level of the root logger to warning by default. To fix this, update the basic config call and set the level to debug. This will guarantee that we will see all log messages. Now run again. If you open the log file once more, you will now see our test message. Notice that the log message displays the level, the name of the logger, in our case root, and then the message. This format is okay, but it's missing an important piece of data, the time when the log message was created. Let's now change the format of the log message. To do this, we will create a format string. Python gives you a wide selection of information you can include in your log messages. You can view these log attributes on the python.org website. In this video, we are mainly interested in the level, time, and message. To change the logging format, create a string with the desired attributes. Let's display the level name, a space, the log time, a dash, then the message. Now pass the format string to the basic config call. Run. If you open the log file, you will see the message now appears in the new format. Notice that the first message is still there. This is because by default, the log file is created in append mode. If you want the log file to be overwritten each time, change the file mode to W. Let's also change the message. Then run. If you look at the log file again, you will see the old log messages have been overwritten, and only our most recent message appears. You can log messages of any level by calling the method with a level name. For example, let's create messages of all 5 levels: debug, info, warning, error, and critical. Now back to debug. Call the function create an info message with the details so you're confident the code is working properly. Equation x squared by solving x squared plus 1 equals 0. Run. We have a problem. If you look at the log file, you'll see only the first 2 debug statements, so the problem must have occurred when we tried to compute the roots. Can you determine the problem? Legend tells of a programmer who never made any mistakes, who anticipated subscribers. You can feel the power by pressing.
Video, I'm going to show off the basics of logging with Python. It's really easy to implement, and it makes your code look that much more professional. It's something you should be including in all your Python scripts. So let's go ahead and just hop into it right now. So I have a script created here, and the first thing I need to do for logging is import the logging module. And then after that, anywhere in my script where I want a logging message, I just type logging.warning.
Hey there,
And then
how's it
within
going,
this,
everybody?
I'm going to put this is a warning message, and it works exactly the same as the print statement. So let's go ahead and run this code here. See, when we run the script, it is giving a warning message, and the output is exactly what we have within the warning message. Perfect. So that looks pretty good. Let's go ahead and have a look at the logging levels next. So I'm going to copy and paste some code here, and these are all the logging levels. Let's go ahead and run this code. And you'll notice it only printed 3 lines there. It printed the warning, the error, and the critical message, but the info and debug are not displaying. And this is what's known as the logging level. Python has different levels in which it logs messages at. And the logging level that you set the logging configuration at, it will print out those logging messages and anything above. So by default, the logging level is set at warning, so it'll print out warning, errors, and critical messages. Now, if we want to change this default, all we need to do is modify the logging configuration. So let's go ahead and do that. And I'll say logging.basicconfig, and you can see it's auto-completing here. And then we're going to send in the parameter level equals logging.debug. And just make sure you're using the proper capitalization there. And now when I rerun, you can see that all 5 messages are displayed. And you can play around like this. So if you wanted just critical messages to be shown, you could go critical, and now it only shows the critical messages. So you can see how good this can be for troubleshooting. You could have only critical messages show up when the application's in production, and when an issue is reported, you could set the logging level down to debug to troubleshoot. So it's very good for categorizing messages within your application. So one thing that I always like to change from the default is the formatting of your logging messages. Just having the debug at the username and then the message isn't enough for me. I like to have timestamps in there. So let's go ahead and add in a timestamp. I'm going to bring this down to a new line here, add another line here, and I'm just going to paste in some code here. And this is the formatting that I usually use. You can look, and then I'm going to go my app as you would print out that there was an error, and we're going to, and then we're going to go.
In this video, we're going to continue learning about logging in Python. Now, if you haven't seen my previous video on basic logging, then you're definitely going to want to make sure that you watch and understand that video before jumping into this one. Now, in this video, we'll be learning about loggers, different handlers, and a couple of other things. So let's go ahead and get started. Okay, so if you watched my first video, then you'll see that I have the same 2 files here that I used in that video. I have this super simple application with some short functions here, and it's basically where we left off in the previous logging video. So just to recap, we imported logging and we set some basic configuration here. The configuration is that we're logging to this sample log file. We're setting the log level equal to debug. And our format, we have a custom format here where we're using the time, the name of the logger, and the message. And then here at the bottom, we are logging out some statements using our logging.debug. Now we have another module here in this employee class where we pretty much did the same thing. We're importing logging. We're setting up our logging with a file equal to employee.log. Our log level here is set to info, and our format for this log file is our level name, the name of the logger, and the message. And then we're doing a logging.info here every time we create an employee. So that is where we left off of the last video. So let me go ahead and run this employee module here. And when I run that, it creates this employee.log, and I'm going to open that up. Now in our employee.log, based on the formatting that we have set, this logs our log level, this root here, and then we have the message that we passed in. So now I'm going to go back to my simple application here, and I'm going to run this. And here we had this set to sample.log, and we can see that that sample.log got created. I'm going to open that up. Now the formatting here we had set a little bit differently. Here we're using the time. So we have the time, this root, and then the message that we passed in. So I said in the last video that we discussed what this root message right here means. And basically what this means is that since we haven't specified a specific logger, we're working with the root logger. And this isn't necessarily a bad thing when working with smaller applications and specific files, but it's best to get into the habit of logging to specific loggers that can all be configured separately. Now we're going to take a look in just a second of how to get a specific logger, but real quick, let me show you why working with this root logger isn't the best idea. So first, let me delete these employee and sample logs here. So I'll delete that employee log, I'll delete that sample log, and close these down. I don't want to save those. Now from within my simple module with these calculator functions, let me import the employee module. So I'm just going to do that right under logging here. I'll do import employee. Now I'm not sure if everyone knows this, but when you import a module, it actually runs the code from that module when it's imported. So when I import my employee module, it should come in here and create these employees and log those. So now from this module where I'm importing employee, I'm going to go ahead and run this module. Now we can see in our file system that it created this employee.log file, but our sample log file that we specified here isn't there. And if I open up my employee log file, we can see that it only logged out our created employees. So what happened here? Why didn't this file create its log, its sample log, and or execute these log statements down here at the bottom? Now the reason it didn't do that is because when we set up this logger here within this employee class, it configures the root logger here with this file name, this log level, and this format. Now all that got set up first because we imported employee, and this module is sharing that same root logger in this script. So by the time we get to configuring our logging within this script, the root logger is already configured with those other values, so this doesn't actually do anything. It doesn't overwrite those initial configurations. Now the only reason our log statements aren't logging down here at the bottom is because the root logger got set to that info level within the employee module, so debug doesn't hit that level. Now if we were to change these here to info statements, and I was to rerun that, now if I pull up this employee log file, then you can see that it did log the information from that script that has the calculation functions. But still, even though we did get those to log somewhere, this is still kind of a mess that we're sharing this root logger. We're not getting the log file that we want, we're not getting the log levels that we want, and we're not getting the formatting that we want. So let's get a new logger for each of our modules so that we can configure both of them separately. So I'm going to go ahead and close this log file down. And within the employee module here, I'm going to create a logger variable, and I'll just do this above our configuration here. So I'll say logger equals. Now to get a new logger, I'm going to say logging.getLogger here. And if this and log the messages to that employee, call this file underscore. Just bear with me here and we'll see how this has a lot of advantages. Okay, so now with this file handler, we want the formatting to be the same as what we specified in our basic configuration. Now I think the code that I have here is just the default configuration anyways, but let's go ahead and add that formatting to our file handler. Now we're going to be adding this formatting to the file handler and not the logger, so keep that needed. Okay, and lastly, let's set the log level on this employee logger. And to do this, we can just come here and log all the lines, create this sample log in so that we're not, so this file handler here .debug. Okay, so now with all those changes implemented our error, created our log files, I'm going to open up our log for an except statement there. I can get more information about what experiments that we're executing down here at the bottom, but we only wanted to display those to the console. So what we do the single logger, do the same.
Welcome. In this tutorial, we are going to learn about traceback module, which provides functions to extract, format, and print stack traces of exception. So in previous section, we saw exceptions. So if we try to print exception, it will print the exception message. And if we take REPR of E, it will print the constructor with its message. But it does not print stack trace like this when an exception goes unhandled. So if we want to access the same stack trace programmatically, or if we want to store that stack trace to file, we can use traceback module and its function. So first we will understand the exception object's structure. So as we can see in this diagram, it contains traceback object, and traceback object contains frame object. So whole traceback object captures the exception details inside it. So it can be later printed or it can be formatted into the different formats. So using this traceback object, which is stored inside the exception object, we can print the traceback. So same traceback object is used by the function which is provided by the traceback module. So first we will access the traceback and the frame object of a exception. So here we are raising exception and we are storing inside the variable E. So, and first we will check the class of the exception, which will be printed as a zero division error. Exception object is having args attribute, which will return a tuple object containing all the argument which is provided to the constructor. To access the traceback object, we can access using special attribute traceback. So it will return the memory address of a traceback object, and if we traverse further and we access frame object from the traceback object, it will print the object type as a frame. So same structure can be accessed using sys modules
So here I can add the traceback somewhere. Maybe I can add it here. This is that our file name traceback, something like that.
exec info function, which will return the information about most recent exception. So it will return a tuple object containing 3 values. First one is exec type, which will contain the class of the exception which is raised. Exec value, which will print the message, and exec traceback, which will return the same traceback object that we can access with the traceback attribute. So let's execute it and see the result. So here the class of exception is 0 division error. A value if args 0, which means first argument is a message. So this is 0 division by error. And if you try to access traceback, it will give you the reference of it. And if we check the type of it, it is type of traceback object. And if we try to access TB frame, it is a type of frame object. So here we can see the object structure in which the traceback information is stored. So same information we can get using sys.execinfo. So exec type, which it is printing the exception class. Exec value, it is printing the message. And exec traceback, it is pointing to same traceback object which is captured by variable e, and its type is traceback. So using this object, we can also traverse to the frame object. So traceback module provides function to extract that traceback information. So we don't need to manually traverse it. So we will begin with the functions. First function is print tb, which prints the stack trace entries from the traceback object tb. It takes 2 optional arguments. First one is a limit. By default, it is set to none, which prints all the stack trace entries. And if it is given positive number, it limits the number of entries to be printed. And if it is given negative number, it takes limit as an absolute value of a given number. And next argument is a file, which is by default set to none, which redirects the stack trace to the std error. And it can be given value as a file-like object. So here, if we are giving file object, the traceback information will be stored to the file. Or if we are providing here std out, so same traceback will be printed on the std out instead of std error. So let's print the traceback. So here we will extract the exception info using sys module, and we will extract the traceback from it, and we will pass to the print tb. Here we are not providing any argument, so it will redirect the stack trace to the std error. Okay, let's execute it. As you can see, std error, it is printing in red. Okay, and it is not breaking the execution sequence. As you can see here, the statements after the write block is getting executed using sys.execinfo, which prints traceback. If it is a syntax error, it is printing the type of error, and it's making this into the returns the list of formatted string, each string containing stack sequence unpacking. So it returns the list of according to our native format. Is format exception only. Returns the list of formatted string containing. So here, if you print format exception only for normal exception, limit, file, and chain. If optional argument limit, file, or chain, it is required. Okay, so here we just want to redirect the traceback to the standard output. So it will fetch the exception information from execinfo, and it will redirect that output to the standard of printing the output to the. Next function is print last. It is a shorthand for print exception to the standard output. Stack trace frame to start.
I think what I need to do is modify the script and play around with this network graph is. By doing that, I'm gonna learn a lot. And once I get what I want, then I start studying the library, the sklearn library, and TensorFlow. Also need to study the PyCharm debugger. But maybe I don't need to use the debugger if I manage to build something that is exactly what I want to build. I think I'm gonna spend the rest. I think I'm gonna spend around 20 minutes doing some typing practice while listening to some music, and then I'm gonna take a break, and then I'm probably gonna come back and watch some C++ videos later. And the next time I'm probably gonna work on the script while reading this documentation and then trying to build the graphs. And I think I'm gonna do probably one of these challenges a day, or once a string, one challenge per string. I think that might be a good idea. So I think I'm gonna listen to some Harry Mack music because he's unbelievably good. It's a little bit loud. Harry Mack. I'm gonna close the window real quick. It's fucking good, man. It's all freestyle off the top, based on the people I see. Guys, unbelievably skilled. I think I'm gonna close here. Already, I forgot to put this timer. Whatever. If I don't come back, I'm probably gonna come back later today and watch some C++ videos from Chile, this guy here. But if I don't come back, I'm not sure when I'm gonna come back because of Christmas. But probably Friday I might come back. And then I'm gonna try to play around with that script and try to build this graph. And if I come back today, I'm gonna watch C++ videos. So, see ya.